Hey everyone, Donovan Brown here. Welcome to the DevOps for ASP.NET Developer Series. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. In this episode, we're going to introduce Azure DevOps. I like to describe Azure DevOps as everything that you need to turn an idea into a working piece of software. This includes work item tracking, source control, CI/CD, testing, and artifact storage. Let's see what Abel and Jeremy have to show us.
What's going on, Abel?
What is up, Jeremy? So excited to be here. Been wanting to do a show with you forever, so this is cool.
This is very cool. In fact, I was excited about the show, put together a little bit of code that we can demo. I got it working and running on my laptop. Last step is just to get it in the cloud so we can both access it.
How are you going to get it up there?
Well, there's this awesome option in Visual Studio to right-click publish. That you look disappointed. Is that not the right option to
No,
take?
there's nothing wrong with right-click publish. It works great, especially if you just want to get your app out into the cloud. But have you thought about building out a CI/CD pipeline?
CI/CD pipeline sounds like a lot of work. I'm a developer. I like to write code. I'm not as much into the ops side of things, if you
Dude,
will.
I get that. Like, I'm a DevOps practitioner, but I kind of hate building out CI/CD pipelines for myself because I like writing code, right? But have you seen the new Azure DevOps toolset?
I've heard about it, but I haven't seen it.
Okay. It is literally everything you need to take an idea and turn that idea into a working piece of software in the hands of your end users. And you can do all of that with just a couple of clicks.
Really?
Yeah. And when I say everything, I mean everything, right? Which sounds like a lot.
It does.
So the way it does that is there are 5 separate tools that work together as a suite of tools inside of Azure DevOps. Now, first, there's Azure Boards. And with Azure Boards, you have the ability to track any unit of work in your software project. So if you do any type of software project that is of any size of all, you need to track your user stories, you need to track your bugs from sprint to sprint, things like that.
So basically all the Post-it notes I have laying around my desk, I can move to something digital.
Yes, you can track it all inside of Azure Boards. And there's a full set of visual tools that will make tracking all that stuff really easy.
Nice.
Yeah. The next thing that you have is Azure Pipelines, where inside of Azure Pipelines, you're able to build out your CI/CD pipelines. And you're able to do this really, really easily. And I'll show you how to do that in a minute.
Yeah, I'd like to see that because it still sounds complicated to me.
The next part is Azure repos. In Azure DevOps, you have the ability to have source code repositories, right? So you can either have Git repos, or if you don't like the distributed nature of Git, you can have a centralized version control system as well. So there are 2 types of version control systems baked right into.
Right into it, okay.
Yep. And then if you do a lot of manual testing, there's Azure Test Plans, which is a test plan suite. And then finally, Azure Artifacts, where you can store all of your artifacts for sharing as well.
That sounds like a lot. That also sounds pretty expensive to me.
You know how much it costs?
I have no idea.
Absolutely free. All you need to do is go to dev.azure.com, sign up for a free account, and then you can start using this. And like your typical workflow, okay, so me talking about all of these separate tools and how they work together and how it's great for DevOps, that's fine. But why don't I just show you what a typical
sounds good.
workflow. All right.
Yeah, because I need to see it in action to really understand.
Okay, fair enough, fair enough. So this is the little demo that I prepared for you. Right here, we have the app that you emailed to me, the Smart Hotel 360.
Sure.
Now, this is a pretty modern app, right? It has a .NET Core web front end. What else does it have?
It's got a mobile backend. It hooks into serverless functions. It's got connections to databases.
Yeah.
So it's pretty comprehensive application.
It looked like it, right? Because you gave me all this code in a repo. So it's a modern application. And what we're going to do is I'll show you, if you use Azure DevOps end to end, what your typical developer workflow looks like and what the benefits will be.
Okay.
Right? So right here, what we're going to look at here is this is your dashboard into Azure DevOps. Now, this is actually my engineering dashboard for my real work that I'm doing. So this is real live data. So what I wanted to show you is this dashboard is fully customizable, where you can make it look and display whatever you want it to do. Right.
This looks like something my manager would get excited about. My
Yeah.
manager loves to see dashboards and widgets and charts,
Yep.
preferably green and moving up instead of down. But
Yep, in graph trends and bug trends and stuff like that. So one of the powers of using Azure DevOps is it's a suite of 5 tools. If you use all 5 of the portions inside of Azure DevOps, all that data just automatically gets correlated.
okay,
So you don't have to use all 5 portions. Let's say your code is in GitHub or maybe you're using Subversion. You can still plug in whatever tools that you are using now into Azure DevOps.
okay,
But if you use all 5 of the tools together, you get an unprecedented view into the health of your project.
makes sense.
Okay. All right. So for this application, let's just say somebody flagged a bug, the future of intelligent hospitality, connected workplace. That's the wrong text, and we need to change that.
Okay,
Right. So typically, what do you need to do? You need to go ahead and create the change, upload it, and then you have to figure out how am I going to deploy this into my dev environment, QA, UAT, and so on and so forth.
right.
And people like your manager, they're probably going to ask, okay, that check-in, what was that check-in for? What work was that associated with? And if you're not using Azure DevOps, it's kind of a pain to try to figure out exactly
Sure,
what
I
those things
usually
are.
just grab the Post-it note. I'm like, it's this pink Post-it note. That's the change I'm working on right there.
Yep. So now you can do it all through Azure DevOps. So
Okay.
let me go ahead and show you. Right here, this is my Kanban board. And this board here displays all the work that I'm doing. And as you can see, it's a very visual board. If I'm working on stuff, I can go ahead and start dragging and dropping items across the board. It's
Very
pretty
nice.
simple, right? Now, this Kanban board is fully customizable, which means you can make this look and behave however you want. The swim lanes are customizable, so I created a super duper important one.
So what you're saying is super duper important and then sort of closed, didn't come out of the box.
Yes, imagine that. Yeah, so I created those just for demo purposes.
Okay.
Right? So you really can make this board look however you want to. You can even customize exactly what shows up on each of the cards. You can customize so that each cards have individual rules as well. So right now, if a work item is assigned to me, it turns it green. But if it's like a priority 1, well, it turns this strange
Wow,
red
okay.
color, right? So once again, you can customize this and make it behave however you need to. So I need to make some work, right? I need to fix this bug,
Sure.
the landing page text. So directly from this work item, I can go ahead and just say, you know what, let's go ahead and create a brand new branch for myself to work in. And we'll call this landing page. And notice it automatically links it up to the work item. I can say create branch, and bam, just like that, it will go into my Git repo and create a branch for myself to fix this specific bug.
Now, I'm a little new to Git, so when you say you create a branch, my understanding is it's sort of a sandbox of the code that I can work with
Yes.
for my change?
Yes.
Okay.
Yes. And we can dive into source control a little bit later.
Okay.
All right. So I've created a branch for myself to work in, and now I need to go in my dev environment and make those changes, right? So let's go ahead and pull the branch down, and we'll go ahead and check out the landing page. And I'm doing everything through the command line just because I kind of like playing in the command line, but there are tools inside of Visual Studio that you can do everything through there as well.
Okay.
I
So it's whatever your preference is, there's a way to do it, pretty
Yeah,
much.
I was born in the world of the command line, so I'm just happy there. All right, so here is my code. Let's add some changes to it. The future of hospitality in connected workplace, let's just say, is able. There we go. So let's go ahead and let's do a git status. And you can see I made a change to a file.
Okay.
I can add those changes, and let's go ahead and commit those changes back up to Azure repo.
This looks so much easier than bringing a floppy disk with it on a zip file, by the way.
Yeah, because then I'll have to figure out where's my floppy disk drive. Does it work with USB-C? I mean, it's such a pain.
So many nuances.
Yep. All right, so let's go ahead and push those changes
Okay.
back up to Azure pipelines, or I'm sorry, Azure repos.
Okay.
All right, so Azure DevOps is actually smart enough, right, to know that, you know what, I just checked in code. And so now it's going to ask me, hey, do you want to create a pull request?
Okay.
Right? A pull request is just a code review. Now, if we're adopting DevOps best practices, we definitely want to do a code review before that code gets merged into master and then pushed all the way out into potentially production.
They may not agree that the future of connected workplaces is able. For example.
Right.
That might come up in the review.
Sounds preposterous to me. But yes, we do want to do a pull request. So let's go ahead and just click on create a pull request, if that's all I need to do. Right? It's going to add my title and the description from my check-in. If I want to change it, I can. Notice that it's still automatically linked to the bug. I can start adding reviewers. So let's go ahead and add Donovan, because I love flooding his email box with stuff. You can even set it up so that depending on which folder the code is coming from, it will automatically assign people to be part of the pull request.
Oh, nice.
So then we'll go ahead and create the pull request. Donovan doesn't have permission. So anyway, I'll just say anybody on my team for now. We'll go ahead and create that. And the first thing you see, this is going to be a timeline of everything that's happened to this particular pull request.
Okay.
So as you can tell, nothing has happened yet, right? Nope. I just created the pull request. So let's go ahead and start this. You can go to Files, and from here, you'll be able to see every single file that was touched and what was changed. Now, for this particular pull request, it's super simple. There's only one. But you can just start leaving comments already. So you can say, I cannot agree with this statement more. And we'll go ahead and add in a comment, right? So hooray for that, we're done.
So you don't just comment on the pull request, you can comment on the actual line of code.
You can comment on the individual file, on the individual line of code. You can comment like an overview over the entire pull request if you want, however granular you want to make it, right? And so as soon as I create this comment, it sends an email and alerts me. Okay. Since I'm the one that started the pull request. So I can go in and look at this and be like, you know what, thanks, that's great. I can even add like an animated GIF or something. Reply and resolve this. Nice. And now if you go to the overview, right, you can see how this timeline actually works. Right? So it's super, super nice.
Very good.
So of course, people usually ask me, what if the statement wasn't positive, right? What if somebody said, no, Able is not the future of connectivity?
Right.
How do you change that, right? So not a big deal. All you need to do is go back to this specific branch, make whatever changes you need to, upload it.
And then recommit it.
Yep, recommit it, and then continue on with the pull request.
Got it.
And at some point, someone's going to be like, this looks great, or they're going to reject it. Right? So for this demo, we're going to go ahead and approve this.
Because if we rejected it, we would stop right there.
Yeah, exactly. Demo over.
Yeah, we want to move this forward. I want to see how these pipelines work.
All right, so let's go ahead and complete this. So once we complete this, there's a couple of checkboxes that make life easier. One of the things is, remember, this was already linked to a bug, right?
Sure.
One of the things that I always forget to do is update my work items.
Mark that it's done.
Yeah.
Right.
So if this successfully merges into the master branch, it will just automatically mark that as resolved.
Okay. Sounds convenient.
The other is it will take this branch and it can automatically, if it merges successfully, it can automatically delete this dev branch for you.
So it's cleaning up your workspace?
Yes. Because what do I always forget to do? Clean up my branches, and so then I'm left with like a million orphan branches.
Sure.
And then finally, the last one is probably my favorite one. This particular branch could have a lot of chatter in it, right? Because I'm checking in, checking out a lot. You're saying you need to fix XYZ, I fix it, I check it in, but I'm not doing it right. So there could be a lot of chatter on this branch. What we can do is we can squash all those changes, so when we merge into master, it becomes one clean commit. So when you read master, it's super easy to read and figure out what's going on.
That is awesome, because when I was looking at Git, I came across a document talking about the manual way to squash changes.
Yeah.
And it looked way more complicated than what I wanted to get
into. You have to memorize all these esoteric Git commands, which I never remember, by the way. So I end up having to jump to Google, searching it, and then typing it in. But now it's just a checkbox.
Okay.
So we'll go ahead and complete the merge. And just like that, it's going to take the code and it's going to merge it back into master.
Okay.
Now, once we merge it into master, it's going to go ahead and kick off my CI build.
Okay.
So let's go ahead and see what that looks like. So here's my build. And you can see my build has already been kicked off.
Wow.
So from here, we're able to see in real time what the build is actually doing. Now, sometimes it takes a little bit of time for it to connect to the agent. So while it's connecting, why don't I go ahead and show you how you set up these builds. All right. So the build inside of Azure DevOps is basically a task runner, right? It just runs one task after
Step
another.
1, step 2, step 3.
Yep.
Okay.
Yep. So what you end up doing is you just drag onto the screen a whole bunch of tasks. These are the tasks that I want to run. Get my source code. Let's go ahead and restore my packages from NuGet. Let's compile everything using Visual Studio. Let's run my unit tests, things like that, right?
Okay.
Yep.
Makes sense.
Okay. So then we wait for the page to load.
Now you know the trick here, right? If you move your cursor clockwise, it should speed up the
It helps
loading.
it go faster.
It helps it go faster. See, I'm telling you, just telling you that tip made it.
It's like
load.
magic.
It is.
So here you can see how I define my build, one task after another after another. First thing that I do is I install Bower, then I run Bower, then I go ahead and scan all of my source code using white source bolts. Then I'm using .NET Core, so I'm going to go ahead and do a restore. I'm going to run all of my unit tests. I'm going to publish my test results. And when that's all done, I'm going to copy everything to a drop location.
Okay.
Right. So it's just like a normal type of compilation. Right. All right. So this build system is fully customizable. You can make it do anything that you want. Right.
Anything.
Anything. So the way that you customize this is by adding and removing tasks.
Okay.
So out of the box, let me just show you, you have hundreds of tasks that you can just start using. Now, of course, there's all sorts of .NET and Azure stuff because we are Microsoft. But this tool, once again, any language targeting any platform. Doesn't have to be .NET. We can do Java, we can do Go.
So my mobile backend application could go through this tool.
Absolutely
Okay.
it can. Absolutely
That's cool.
it can. So then people sometimes ask me as well, this is great, you have hundreds of tasks out of the box, but what if I want to do something that's not out of the box?
Right.
Not a big deal. I would look in the marketplace. In the marketplace, our partners have created over 500 build and release tasks that you can just download and start using.
Very cool.
And if what you want to do doesn't exist out of the box and it's not in the marketplace, still not a big deal because you can write your own custom tasks.
Nice.
Yeah.
So it's basically, if I have it, I'll use it. If I don't have it, I'll buy it. If I can't buy it, I'll build it.
Yeah, pretty much. Although buy it, most of these tasks are free.
Most of
too.
them are free.
Yeah, so just download
Nice.
it. But yes, that's pretty much the concept. Building a custom task, super easy. It's Node.js or PowerShell.
Okay.
So what that means is anything you do from the command line, easily you can get this build and release system to do. Which also translates to you can get this build and release system to do whatever you want.
Sounds good.
Yep. All right, so the build should have progressed pretty nicely. Let's take a look and see where we're at right now. So here is the live view, right, where you can see live exactly what it's doing from one step to the next to the next. And it's just showing all the command line.
Now, did someone have to configure a server and set up a build machine for this? Like, I've been tasked with that in the past, and that's a pain.
You know what?
Getting a build machine perfect for your job.
That is a great question, because if you wanted your own build server, you could, or you could use our hosted build agents. So what we've done is we have a whole pool of agents hosted up in Azure that people can just start using.
Okay. That's pretty cool.
That's it. It's loaded up with a standard set of tools, and every month we publish exactly what tools and what software are on our agents. If what you want has to be installed using a GUI, then you have to have your own agent.
Okay.
But otherwise, you have control over that agent while it's running. Now, the cool thing is we offer agents not only for Windows, which makes sense, but Windows, Linux, and Mac.
And Mac.
Specifically because you know how like in iOS apps, you have to have a Mac to compile
Sure.
it? Right, that's the licensing thing. So because of that, we actually have a pool of Macs that people can use. So as a .NET dev, if you're using something like Xamarin,
Right.
you can literally be an iOS dev, but not own a Mac.
Not on a Mac.
Yeah.
Wow.
And once again, you get all of this for free.
Okay.
All right, so the build just finished. And what we can do now is take a look at that build report. Right, so let's go ahead and go to the summary. And you'll see a really nice summary that shows everything that's happened. And this is kind of what I mean about you have that full end-to-end picture. We have the check-in for this particular work item. these are all live links, right? So I can click on this link and actually see which file
Drill
is checked
into
in.
it. Yep.
Here's my build. I can see the errors, the warnings, the tests, which tests have run, which ones have passed, which ones have failed. It created my drop for me. And now it's going to go ahead and start deploying my application for me. So sending it through a deployment pipeline as well. So let's go ahead and jump and look at the deployment pipeline. So here's my deployment pipeline. It's running, I guess, in real time. So I'll go ahead and show you how you set this up. Right. First thing you do is you set up your stages. Once you set up your stages, I have a dev stage, a QA stage, and a prod stage. Then you can set up approvers before and after each environment. Right? So when it goes from one environment to the next, you can have an approver.
Right.
So you can set up manual approvers, and you can set up, like, I don't know, a list of people where every single person on that list has to approve before it can go to the next environment.
Okay.
Or you can have a group where if one person approves in the group, then it will flow through. Or you can have none at all, right, where it just can automatically go from one environment to the next as well. So you can really tighten this down as much as you need to, or open it wide up if you want.
It's nice that it has that flexibility.
Yep. All right, so let me go ahead and also show you, let me go ahead and jump to the releases and show you how you can set up the individual release as well. So let me hit edit. So you set up your environments, you set up your approvers before and after each environment. Then you would go into each one of your stages, and now you're going to add the tasks that you need to deploy your application into that particular stage.
Okay.
So this task engine, just like the build, because it's literally the exact same engine.
So the build was dealing with taking my source code, running tests, creating the artifacts, the output from the build.
Yep.
This is going to take that output now and deal with how am I going to run it? Am I deploying to, it looks like here, Azure deployment, create a resource group, web app, Azure resource management template. So infrastructure as code and all these cool buzzwords that.
Yep. So the first thing that I do is I go ahead and deploy the environment out in Azure using an ARM template.
Okay.
And
so you're actually setting up where it's deploying to.
Yeah.
Nice.
Yeah. So I start from nothing at all, and then it's going to create for me the environment in Azure using an ARM template. And then I'm going to take the compiled web app that we did during the build, take those binaries, and I'm going to deploy that into Azure.
Nice.
So once again, fully customizable. You can make this do whatever you want by adding and removing tasks. So this is just like the build, right? Hundreds of tasks out of the box. Go to the marketplace. If it's not there, not in the marketplace either, write your own task.
Now can this, for our mobile app, we now know that we can compile it on a Mac machine without me buying a Mac, which is great. Will it deploy it to the store?
You actually can. And I'll show you how to do that in just 1 second.
Okay.
All right. Very, very good question. All right. So let's take a look at our pipeline and see how our release is going. So here we go. Looks like we've released all the way out into dev, and now it's waiting for QA, waiting for an approval.
Okay.
So if we jump back to our app, let's refresh this and see if the changes happened. It's refreshing.
Telling you need to do the cursor trick.
I really do.
That's the secret.
See, once you bring it up, bam, it's done.
There you are. Able.
Successfully done. So as a developer, this is super easy, right? Once I have this set up, literally all I do is check in my code, and all of this happens.
Wow.
So one last thing I wanted to show you is, let's go ahead and jump to our pipeline again. Oops, that's my super pipeline. You can notice it's pending approval on my QA environment.
Right.
So I can go ahead and approve it, and immediately the bits will start flowing into the QA environment. I can also defer my deployments, which means I can schedule my deployment for later, right? So I can say, I do approve this, but let's do this at Saturday at 2 in the morning when no one's on the system, or something like that.
Sounds good.
So I'll go ahead and approve, and immediately bit starts flowing into the QA environment. So earlier you were asking me about the iOS build, right?
Right.
So what I'll do right now is I'll go ahead and show you what the all-up build for Hotel 360 looks like. You know we have our web front end, right?
Right.
There we go. We have an API service, and I took your code and I put it into a Kubernetes cluster just because that's what I was working on recently, and so I thought it would be kind of cool.
Okay.
So for the API service, I build everything, and at the end result is going to be a container image.
Right.
So I take that and I create a Helm package out of it, and then finally I have a build for the iOS. So this is 3 parallel builds that run all at the same time with one check-in.
Nice.
Just to show you that this is real, right? For the web app, I'm using a Windows agent.
Okay.
For the API service, I'm going to use one of our Linux agents.
Okay.
And then finally, for iOS, I'm going to use
Mac OS.
the Mac OS. And when this build is finished, it goes ahead and triggers a release. And once again, I have one release, 3 parallel tracks that will deploy my entire application, all parts of all microservices, right? We got the web front end, the API, and the mobile, all the way out even into the App Store itself.
Nice. That's pretty amazing.
So this is the power that you can get, the power of DevOps using Azure DevOps.
I'm excited. I definitely want to drill in. It looks like it does everything. It looked easy, but I want to figure out how to set this stuff up myself. So I think we should dive into it a little deeper.
Absolutely.
Sounds great. Well, thanks for coming over and showing me this awesome tool. I'm excited about transforming the application.
Cool. Let's do it.
All right.
Hey everyone, Donovan Brown here. Welcome to the DevOps for ASP.NET Developer Series. In this episode, we're going to focus on source control. When using Azure repos, you have 2 options: Team Foundation Version Control, or TFVC, and Git. TFVC is centralized and Git is distributed. We offer both options because they both have pros and cons. Depending on your team's workflow, you can select the system that works best for you. Let's see which system Abel and Jeremy decide to use.
Wow, last episode you shared so much information on Azure DevOps. It was really exciting, but one of the things that stood out to me was that there's probably a better way for me to manage my source code than the way I've been zipping it in a file and emailing it around. So I looked online and Azure DevOps supports different types of source control, but there's options for GitHub, there's options for distributed or not distributed, and I was a little bit overwhelmed with how to get started. So can you tell me a little bit more about what's available and how I choose?
Yes, absolutely. And I'm so glad you are planning to move away from the zip files. So inside of Azure DevOps, there is a tool called Azure Repos, right? And inside of Azure Repos, that's your source control system.
Right.
So there are actually 2 types of source control systems that's built right into Azure Repos. There's a distributed system, which is Git, and then there is a centralized version control system as well, which I believe we're calling it TFVC, Team Foundation Version Control.
So someone who's been using Team Foundation services, which I've used in the past, that would be that traditional source control.
Yeah, it's the same centralized version control system.
Okay.
And there are times when centralized version control systems makes perfect sense. And I know Git is the shiny, popular version control system that everyone likes to use these days, and actually I'm a huge fan of it as well. But there are some instances where it doesn't make sense to have a distributed version control system, and then you have TFVC that you can just use.
Okay.
Right. So when you go ahead and create a brand new repo, from here you get to choose the type. Do you want it to be a Git, or do you want it to be TFVC?
Okay.
And it literally is that easy, and that's all you need to do. Some benefits of Git, though, like I said, I'm a huge fan of Git. Some benefits of a distributed system. One of the things that I like the most about it is that you're able to create your branches really quickly, easily, and fast, right? And they're super efficient as well because they're literally just pointers.
Okay.
So I can spin up local branches, like 100 of them, and it's not going to bog down the server itself. Whereas if I'm using a centralized version control system, every branch that I'm making, even my local, quote, local branches, they have to be pushed to the centralized server first.
So it's creating a workspace there as opposed to Git, which is just a local space that you work on until you're ready and then you push it up.
Yep.
Okay.
And if need be, you can go ahead and take those local branches and upload them up to Git, or wherever your repo is going to be as well.
And it seems like Git is so popular that if I have a development team that has a background used to working with Git, that having that as an option means they're going to be able to use the tools that they're familiar with.
Absolutely, right. And so that brings up another good point, which is use the tools that make sense for you.
Right.
So if you're not using Git and you're using a centralized version control system and you're not having problems with it, why change? Exactly.
Right.
Now you don't need to. And also, if you happen to be using a version control system already, right? Some people use Subversion, some people use GitHub, some people use some other external Bitbucket. There's all sorts of different version control systems out there, right? One of the most amazing things about Azure DevOps is use the tools that you're comfortable with. You don't have to use all 5 of the tool set inside of Azure DevOps. Just use the ones that you want, and you can literally link together all the other tools just like with Lego.
So with everything you showed in the last episode, automated builds, deployments, if I have a project over in GitHub, not inside Azure repos, it can still plug in to all of these other features that Azure DevOps provides.
Absolutely. So GitHub is a special case, right? Because GitHub is a first-class citizen inside of Azure DevOps. You can literally do what our end goal is. We want to make that experience of Azure DevOps with GitHub to be completely seamless to what you would see using like a Git repo inside of Azure repos.
Makes sense.
Got confused there for a second. But yeah, it's so GitHub's a special case. It is absolutely a first-class citizen. But let me show you what I mean here. If I go into a build definition, and from my build definition, let's go ahead and edit this. You'll be able to see when I do a get source, I'm able to get, of course, from the Azure repos. Right?
Okay.
I'm also able to pull from GitHub, Enterprise GitHub, Subversion, Bitbucket, or an external Git system.
Okay.
So out of the box, you're able to use all these different source control systems, and away you go.
Are you able to, is this for the entire build, or is it per, so if I have multiple source repositories, maybe I'm a large organization and I've acquired a company that has it somewhere else, I can create different builds that pull from different places?
Absolutely. So in one Azure DevOps project, which is what this is, you can have literally unlimited repos.
Okay.
Free, unlimited.
Free, unlimited repos.
Yeah.
Wow.
So you can have as many as you want inside of Azure repos. And if you have like 50 Git repos as well, you can pull those in.
Okay. Yep. Sounds good.
Yep. There's some fun stuff that you can do as well. So for instance, if you're using one of the repos inside of Azure repos, you can set up rules, right? So let me show you what I mean. Let's go ahead and go into our project settings. And from our project settings, we're going to go ahead and look at the repositories.
Okay.
So in this repository, you can see I have one repo. I can see all the different branches that I have. In this case, I only have a master branch. But this is what I really wanted to show, is for each branch, you can create your own custom branch policies as well. So you can do things like, you can set up rules. So before the code can get checked in, it has to go through a pull request. Right? So you can tighten this down so that not anybody can just check in and
right, we're just not haphazardly throwing code into the production line.
So you can require things like the minimum number of reviewers. So you can say you have to go through a pull request and 3 people have to at least check the code before it can be merged into master. You have the ability to check for linked work items. So you can even block a pull request if it's not linked to a work item even.
So we can tie it to why the change is taking place. Is this a story? Is this a defect? Something else?
Yeah. So by forcing your devs to do this, and I know devs cringe because none of us like to do that stuff, but like I said earlier, you get an unprecedented view into the health, right? You'll be able to track everything. You'll be able to do things like this particular bug. Did it reach production yet? And you can literally go from the bug and say, oh, I see Jeremy checked it in yesterday at 4 in the morning, because he works late.
Because that's how I roll.
That's right. And it kicked off this specific build, ran all of our unit tests, everything looked good. It automatically deployed into the dev environment where our devs played with it, looked good. Maybe I approved it, flowed into the QA environment. The QA testers started testing it, and it broke on these 5 tests. And so it did not get into production. It died in QA.
And here's exactly why.
Yeah, and you can see that entire path.
Nice.
That's the power that you can get.
Now, can you link, if I'm pulling from one of the third-party source control systems, can you still link
To work
activities
items?
to work items?
Well, I know with GitHub you can.
Okay.
Yeah, I'm not sure about the other ones just because I haven't used them.
Okay.
But I'll have to play around with it and see.
Sounds good.
Yep. Some other things that you can do, you can make sure that there are comments for your resolutions instead of just, check, 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 check. And of course, you can enforce different merge strategies as well. Something else that you can do, this one is one of the things that I love the most. When you do a pull request, instead of just having people check the code before human eyes even looks at it, you can force it to kick off a build.
And make sure the code at least compiles.
Yeah,
right?
before I look at it,
First line of
come on.
defense.
Yeah. At least it should compile and it should run all of our unit tests.
Sure.
If it doesn't even do that, why am I wasting my time looking at it?
Right.
So you can do that as well. So that's one of the super, super useful things as well. And of course, in this section here, this is where you can automatically include the code reviewers based on which folder your code is coming from.
Nice.
So super powerful, super useful. And I love the integration between Azure repos and Azure DevOps in general. But once again, it's really, really simple to do things using GitHub and those other services as well. So I thought what I'd do is just show you how easy it is to use a GitHub repo.
Okay. Sounds good.
All right. So it is literally as simple as going to your build. Let me go ahead and cancel this out, and let's go to a build. And from the build, we'll go ahead and edit this. It can be as simple as saying, get your source. We're going to grab it from GitHub. It's going to want it. I'm going to access this with a token because I think I still remember my token.
That was some of the fastest typing I've seen.
What can I say? And now you'll be able to see all of my repos inside of GitHub. So let's go ahead and grab something. We'll do my Learn DevOps. I'll go ahead and select that, and we'll save it and queue it.
So now it's using the build pipeline you've already built out, but it's grabbing the source instead of from the Azure repo from the GitHub repo.
Exactly.
Okay.
And it's literally as simple as that. We're done.
Wow.
Right. So now we're grabbing the code from GitHub, and all I needed was an access token.
That's nice.
So if you happen to be in the GitHub world, you can do this from GitHub UI as well. So let me show you what I mean.
And this is something I'm interested in because now that I know this is free, I have several GitHub projects, and it'd be nice to go ahead and integrate those into some pipelines.
Oh, I need to sign in, not sign up. All right, let me go ahead and sign into my account. And to create a build pipeline directly from GitHub, super easy to do. What you want to do is you want to install the right marketplace extension. So let's go ahead and search for Azure Pipelines. And you'll see that I've already created one, or I've already have this installed. But we'll go ahead and configure it really quickly, or at least I'll show you how it's configured.
Okay.
You just come in here to configure it, and from this UI, it's going to ask you which repo do you want to create your build. So we'll go ahead and select my current repo, which is my Tailwind front end, click on Save. Now it's going to take me back into Azure repos, or it's going to take me into Azure DevOps. It's going to ask me to sign in, and it's going to say, okay, which team project do you want to use, right? So it's going to show all of my orgs right now, which is going to be a lot, because I have way too many orgs.
Well, you are a DevOps practitioner, so.
Yeah. Hopefully, most normal people won't have this many orgs. All right, so let me go to my demo account. We'll select a project.
So just for me to clarify, what we're doing is taking a repo in GitHub, linking it to a project, which is an umbrella for all these different work items and pipelines and other things we can do with Azure DevOps, and marrying the two together.
Yep.
Okay.
Just like that. So I started from my GitHub repo. I went to the marketplace, the GitHub marketplace, to add the Azure Pipelines marketplace extension. And that in turn logs me back into Azure DevOps, where it says, hey, do you want to create a pipeline? Which of course I do, and it goes ahead and creates for me a pipeline. And in this case, it's going to create for me a pipeline using YAML. So I can go ahead and click it, run it, and hooray for that, I'm done.
So did it sense, I guess, the type of project you have and generate that?
It did. It's actually smart enough to figure out exactly what technologies are being used, right? So the marketplace looks at my repos and says, okay, this is a Node application, or this is a Java-based application, or this is a .NET-based application. And because of that, these are the steps that people normally would take. And so then, bam, it creates for us a build that's in YAML.
And when you saved it, it immediately kicked off a build?
Yeah, just like that. Yeah.
Nice.
So what is this build doing? It's downloading the latest code from GitHub, right? Compiling everything and running the build steps that were defined.
And if I'm on GitHub already, have a free repo, this is again a free service I can use to build my project. Now, what is the experience like the first time I log in if I don't have an account with Azure DevOps? Does it just prompt me to create one, or does it use the GitHub login? Or
yes. It takes you to dev.azure.com where you just sign up for a free account.
Okay.
Yep.
Sounds good.
So super easy to do, no matter what repos you're using. Personally, I love using the repos inside of Azure Repos. I love the pull request experience that I showed you in the first video we did. That's a really, really nice pull request experience. I also like using the repos from GitHub just because all of my open source projects, and they're there, right? So it's nice to have that integration as well. But remember, if you're using something like Subversion or your own external Git system, you can plug that into Azure repos as well.
Very nice. So this is pretty much the last time I'll ever zip up source code again.
Yes.
I've got a free solution. Might as well take advantage of it.
Yeah, and I do mean free, unlimited private repos. So if you want to have 10 million of those, okay, the team's probably going to kill me. But yeah, if you want to have a whole bunch of them, you can.
Yeah, hopefully I don't have enough time to build 10 million repos.
Right.
That'd be a lot. This is awesome. Thank you so much for sharing that.
Absolutely.
Hey everyone, Donovan Brown here. Welcome to the DevOps for ASP.NET Developer Series. In this episode, we're going to focus on work item tracking. Using Azure boards, you can plan and track your work using product backlogs, task boards, and Kanban boards. You can also plan your releases using delivery plans. You can also customize the process templates to fit your team's specific needs. Let's see how Abel and Jeremy plan their work.
Abel, earlier we were talking about all the Azure DevOps functionality, and you touched on a piece of it called Azure Boards.
Right.
And that's something, I mentioned I have Post-it notes all over the place to keep track of work.
Yes.
And you said we could track everything from any type of unit of work, defects, etc. Can you dive into that a little bit more?
Absolutely. So like you were saying, with Azure Boards, you have the ability to track any unit of work for your project. Now, everything is really kind of geared towards an agile type of methodology, right?
Okay.
But there are a couple different methodologies that you can use. So why don't I just dive in and start showing you?
Sounds good.
All right. So what you need to do, the first thing you need to do is you need to create a project inside of your Azure DevOps organization. So let's go ahead and create a brand new project. So we'll give this a name, and we'll call this Demo 2. And before we create it, let's open up the Advanced window. And you can see you have choices for the version control system that you want to use, and also the work item process.
Okay.
So depending on the process that you choose, that will change the work items a little bit. So inside of Agile, if I choose Agile, what you'll end up getting is you'll be getting things like user stories and impediments and bugs and things like that, and tasks and epics and so on and so forth.
I don't want any impediments, so I wouldn't choose that, right?
Right. If you use Scrum, then all of a sudden you start getting work items that are Scrum terms. Like you have backlog items instead of a user story.
Okay.
And the states will be a little bit different. And then finally with CMMI, then you get another set of work items as well.
Okay. And is there a way to reference or see sort of an overview of how these different processes compare to each other? Do we have that in docs somewhere?
Absolutely. Just go to docs.microsoft.com and you can, I'll post the URL at the end of this, and you'll be able to see and read exactly which each process template does.
Okay, great.
All right, so for this demo, we'll go ahead and just choose Agile, and we will create our new project. And so now it will go ahead and create our project for us, and once it does that, I can show you the different type of work items that you can actually go in there and create.
Okay.
And actually, while it's creating here, oh, it's already done.
Look at that.
We'll jump into the boards. And the first page that you see, this will just show you all the work items that have recently been updated or created or anything like that. But when I introduce boards to people, what I like to do is I like to start from the backlog level. Because most Agile projects, what you want to do is you want to start with a backlog.
Right, it's the things to do, basically.
Yeah, a wish list, right, of everything that you want.
Right.
So I was recently on a project where somebody actually put on their backlog they want a time machine. And it got prioritized really low,
right?
But it always stayed
So
there.
it's on the backlog, it's in the back of mine, but it might be a while before that's
Yeah, I don't think we're going to get to it
something
anytime
to
soon.
tackle, right?
Yeah, but the whole idea of the backlog is you just throw everything that you want on there, and then you do need to prioritize that, right?
Right.
So this right here is our backlog, so we can go ahead and start adding work. So let's add a new user story. Because I'm so original, I'll just do this. We can add another user story.
User story 2?
Yeah.
Okay.
I'm going to add one more.
I'm going to guess this is user story 3.
Man.
Right, you up in the search bar now. There we go.
There we go. Right?
Okay.
So notice this is just a list, right? You can organize it by dragging and dropping.
So you just prioritize user story 3 above user story 2.
Yep.
Okay.
So prioritizing, super, super easy. You can just move things up or down.
Okay.
Right. Drag and drop, everything works great. The other thing that you can do is you can click on the user story itself, and that will open up the user story, right? Because so now not only do you have a title, you can add a description, you can add acceptance criteria, you can add discussions. I can do things like, let's send an email to Donovan. That's always fun.
This work item is messed up.
Right. So then, of course, I can save it, and as soon as I save that, it will send Donovan an email saying somebody's asking you a question about this, and then he can come in here and
Add
answer
another comment of his own, or
Yeah.
okay.
So this is kind of cool. What I like about this is it captures that type of back and forth questions that a lot of people have, but it captures it all within the work item, so that's tracked, and you can always go back to it and see what's going on. As opposed, a lot of times it's like in a Slack channel, and then, well,
Then you
Slack-
lose it in the
Yeah.
flow. It scrolls away.
Yep.
So it sounds like both for remote teams and for teams that might be together but prefer asynchronous collaboration, this is a great way to capture threads and discussions relative to backlog items.
Absolutely, absolutely. So here we go. We create a backlog full of user stories, right? The other thing that we can do is we can break apart our user stories down into individual tasks that developers need to do. So the way I usually like to scope things is I like to say, tasks, let's make tasks something that you can get done within a day. So like 3 to 5 hours worth of work. And if it's bigger than that, it probably should be a user story. And a user story, it should be small enough that you can finish it within your sprint.
Right, an increment of delivery.
Yep. And then if it's bigger than that, then maybe it needs to be turned into an epic, or maybe it needs to be turned into a feature, right? It just slowly gets bigger and bigger.
Right, okay.
So anyway, we can take our user story and break that down into individual tasks. Let's go ahead and add a task. I know, I'm so original, task 1.
Yeah.
And we'll add a couple of them here. Let's add another one.
I'm thinking task 2.
You're just brilliant. And for user story 1, let's go ahead and add one for here as well. And we'll call that task 3. All right. So it's easy enough to create your wish list. You can prioritize it, and now you can break down your work into individual tasks. Right?
Okay.
And this whole UI is fully drag and droppable. So if I really wanted to, and I wanted to reparent this, I can drag this and reparent it just like that as well.
Okay.
So super easy to manipulate the things that you want to do. Right? So this is great. Then you can start taking your tasks, and notice we have all these different iterations, right? Iteration 1, iteration 2, iteration 3.
Right.
So these would be like our individual sprints. So if you have a really, really long backlog, you can start dragging your work into your different iterations as well.
So this is, we're basically committing to what we're going to do in the first iteration and guessing at what is feasible down the road.
Yep.
Okay.
Yep. So this list is great in terms of adding work, or maybe even doing some super high-level projection of, I think we're going to get about this much done, by this date. But what it's not good at is tracking your work on a day-to-day basis.
Right. So we have the daily stand-up or whatever, and
Yes.
we want a snapshot of just what's important for that day.
Yeah, we're just for that sprint, right?
Right.
Let's say our sprint is for 2 weeks or something like that. So then we also have a sprint view, where if we click on sprints, it'll bring us to the sprint the current sprint that's running. And you notice we have the 2 work items broken down into the tasks. And of course, as user needs to do their work, they can just start dragging their work across the board. Well, assuming I drag it all the way over there. Let me try that again. Okay, well,
Right.
I can't resolve it right now, but anyway. So you can just slowly walk your work items all the way across, just like that. Right? So in a visual manner, you'll be able to see everything that's happening from one day to the next from your sprints. And by updating your work items like this, this will automatically update the times and everything like that, which means all of your burn down charts and burn up charts, those automatically get created for you.
Nice. So these are, when we looked previously at source control and we were mapping a check-in to a work item,
Yes.
these are the work items we can associate with, and this is a view we can take. Now, will this view allow us to drill into related changes? Does it work both ways?
Absolutely, it does. So let me jump to a project where we've actually done something, which in the last episode, let's look at this work item. Landing page text is wrong. I did a couple check-ins for that, right?
Right.
If we look at this, under development, here are all the changes that I made.
There it is, right
And these
there.
are links. So this is when I did my merge, and I can just click on it, and it'll take me directly to what happened during that merge.
That's nice. I love that integration to get exactly where you want to go.
Yep, yep. So the other thing that I wanted to show you is for each of these individual work items, you have the ability to link them as well. So there's like a parent-child type of link, so you've got a user story that's broken down into tasks. And so your related work, you can use the UI and it'll link everything for you automatically, or if you want to link things in a manual type fashion, you can do this as well.
And create a new item on the fly.
Yep.
Okay.
Yep. So once again, this really helps with the project planning. Like as a developer, a lot of times when I first start my sprints, we break things down into user stories, and then when we have our first sprint planning meeting, I try to start estimating or breaking apart the user stories into tasks that I think I'll need to do to finish that particular user story. And then that gives me a pretty good idea of how long it's going to take for me to finish that user story.
So how much flexibility do we have with this board? I know some teams may like the statuses out of the box that goes left to right to close. So I may want a preliminary step, or I noticed you did some custom swim lanes earlier.
Yeah, so let me go ahead and jump over to the boards again. So this is our backlog, right? As soon as this refreshes. I'm going to jump into, this is the boards view.
Okay.
Right? So before, we were looking at something as a backlog. It's just an ordered list. Not very good at tracking your work. But if you go to the boards, that's when you can start seeing everything in swim lanes, columns, et cetera, where you can start dragging your work across. Right?
So this is the Kanban board style, right?
This is a Kanban board. Now, this board here is fully customizable, where you can make it look however you want to. So you can add your own columns, you can add your own swim lanes, you can add rules to, say, if it's a priority 1, you can change the color of the work item as well. You can add whatever field you want onto the card, right? Fully customizable.
Okay.
So the way that you would do that is from the board itself, click on the gears, and here this will pull up menu settings for everything that you want to do, right? So for instance, if you have a user story, you can show, do you want to show these fields? And then if you want to add additional fields, you can as well. So maybe we want to add a field. Let's add the priority. We'll go ahead and save and close that. And then you'll notice everything starts showing the priority.
Nice.
Right. If we want to add some swim lanes or some columns, let's go ahead and add a swim lane. We'll go ahead and save it. And immediately refreshes with that. Right. If you want to add your own custom columns, you can as well.
Okay.
Yeah. Another thing that I like about this is it does show all the tasks that are associated to this particular user story. And as they're finished, they get crossed off.
Now, one of the things I noticed is as you were working on this board, in the upper right, we started seeing some of these charts refresh.
Yeah.
So tell me a little bit about those charts. What do those do?
So this is a cumulative flow chart. So as you're adding work and as you're finishing work, it'll start showing up on this. So these are charts that if you have like a Scrum Master, they can use that to judge and view, oh, how's the progress? What's the progress my team is using?
So this is how we can do projections and estimates, right? We start to see closing between open and done tasks, and where they converge is where we think will be done.
Yep.
Okay.
Yep. And the other thing that I really love about this Kanban board is I can start creating work directly from this Kanban board, right? I can start creating branches for myself to work in. So I showed this last time as well, but we can just go to the work item itself, create a new branch, and then that right there will create the branch for you and automatically link that branch with your work item.
So in a workflow as a developer, if I've just finished a task, I could go to the board, what's the next priority item I have for the sprint, start with the new branch, and get right to coding automatically.
Yep. And all of that linkage of this particular branch is for this particular work item. As a dev, I don't have to worry about that anymore. When I check in my commit, I don't have to say commit, pound, and oh, what's the ID number, right? And to get the linkage working. That linkage will just automatically happen for you.
That's nice.
So super powerful, super useful. The other thing that I wanted to talk about this is that all of these work items, these are fully customizable as well. So out of the box, you get a bunch of fields, right? You get things like the title, the states, the description, acceptance criteria, planning story points, priorities, so on and so forth. You have some other tabs as well that you can go to. There's a history tab as well. Oh, I should mention this as well. Everything that you do on a work item is tracked and saved. So the historical tracking of what happened to this work, that is all tracked through this the history field as well.
And this is even linked items, so as statuses change because of builds or whatever.
Yes.
Okay.
Right. So this is what I mean about if you use Azure DevOps end-to-end, right? All 5 parts of the suite. You get this unprecedented view into the health of your project. You start seeing everything that's happening, right? You can see all the linkages, and of course you can also attach things. Right, so this is like an email attachment. You can attach images,
maybe have a storyboard, something like that, related to the item.
Yep.
Okay.
Yep. So super, super useful. But a lot of times people tell me, this is great, but I need some extra fields. Can I add extra fields? Or maybe I want to change the way the states work. Can I change, they want to customize it, which makes perfect sense. And the answer is yes, you absolutely can customize these work items. You can add fields. You can even create your own work items if you wanted to.
Okay.
And the way that you do that is, let's go ahead and go into project settings. And then from project settings, go to project configuration. And it says this project is currently using Agile, right? So if we wanted to customize this, we can go ahead and go to the process customization page. And it's going to tell us you can't customize this because this is the Agile template.
It's the built-in template for Agile.
But what you can do is create an inherited process.
Okay.
So it will inherit the stuff from Agile, but then now you'll have the ability to come in here and start modifying it. So we'll call this Able Agile.
So if I want to do this, basically, I'll pick whichever built-in process is closest to the one I want to create.
Yes.
Start with that, and then I can start changing things around.
Yep. So now you can add new work item types. You can drill into a specific work item and add and remove fields and change things as well. Right. So you can really customize these work item templates so they work in the process that you want them to work.
Very nice. Now, is this something that, let's say I'm managing a huge set of teams, and I have a process that I want to be repeatable across projects.
Yep.
Do I have to customize each time, or is there a way to export the settings and import? Or
That's a great question. All you need to do is just create your custom template once, and then now when you create a new team project, it will go ahead and remember that drop down where it said Scrum, CMMI, and Agile? It will have all of your custom templates.
So it'll have
as well.
Able Agile.
Yeah.
Now. Okay.
So then the rest of the teams, that's the one that they would use.
Got it.
Yep.
Makes sense.
Yep. Super powerful, super useful.
Sounds that way.
Yeah.
Awesome. Anything else to share?
Go to dev.azure.com, create yourself an organization, create yourself a team project, and start using Azure boards. The only other thing that I wanted to say is that if you're using GitHub, we do have GitHub integration with Azure boards as well. And that's easy enough to set up. So you'd go into your project settings, go to GitHub connections, and from here, you would connect up to your GitHub account. And then now you have two-way integration between GitHub and your Azure boards as well.
So is this, so I understand issues and work items in GitHub?
Almost, but not quite. Right?
Okay.
So this is a work in progress right now. There is no integration with the issues, but issues are great, right, in terms of hey, something is happening in my open source project. Cool, it's an issue. Let's fix it. Let's do whatever. So that works great for that. But if you wanted a little bit more power, a little bit more flexibility, a little bit more control over your different work items. For instance, if you wanted to track a full project, you can't track a full project with issues.
Right.
Exactly. But I can track from sprint to sprint with boards. But then if I set up the integration correctly, then I'll be able to, as I do my commits, I can say pound whatever the number, and it will automatically link back up to.
Okay, so I can have my work items in Azure boards reference the issues in GitHub.
Yes.
Nice.
Yep.
Very good.
Yep.
Great. Well, it sounds like this will simplify things, save me buying a lot of Post-it note paper and pens. Thanks for sharing this.
Absolutely. Thanks, man.
All right.
Hey everyone, Donovan Brown here. Welcome to the DevOps for ASP.NET Developer Series. In this episode, we're going to focus on continuous integration. Continuous integration is the act upon every commit the code is downloaded, compiled, tested, and packaged for deployment. Using Azure pipelines, you can create CI for any language. Let's see how Abel and Jeremy enable CI for their project.
So far, we've covered quite a bit. We've talked about sort of the overview of what's available. You showed me how to get code into source control and what the options are, and we went through work items.
Yes.
Now, the next step that we're going to drill into is pretty exciting to me because this is something that, in my history as a developer, in the old days, we used to have to build our software on our machine, kind of stage it, move it to another machine, or set up a build machine, get all the installation and references and dependencies set up on that machine, and then we'd build that, and then we'd take it, and it still would have issues, right, on the production machine. Now, I understand that if I want a clean build process, that I can use Azure pipelines to do that, and it's not just take this project and build it, but there are steps and customizations and other pieces to that. So I'm really excited to dig into what's available.
Cool, man. So Azure pipelines, inside of Azure pipelines, you have the ability to create build and release pipelines.
Okay.
So today we'll just look at how you create build pipelines.
All right.
So let's go ahead and create a brand new one completely from scratch. And we'll create a new build pipeline. And first it's going to ask me, where is your code sitting? Is it in Azure repos or is it in GitHub? Because remember, when we talked about source control, GitHub, first-class citizen, right?
Right.
The thing is, it doesn't have to just be inside of Azure repos. It can be in a lot of other places as well. So this right here is just a wizard that kind of quickly walks you through how to do things. So if you want to do everything manually, you would just go ahead and say, use the visual editor.
Okay.
So for this demo, we'll just go ahead and use the wizard.
Okay.
So my code is sitting in my Azure repos, and I only have one, which is DevOps for ASP.NET Core application. And notice it analyzed my repo, right? So because it analyzed it, it figured out, okay, this is an ASP.NET Core application. And now it's offered me a couple templates that make sense. So I'm going to go ahead and choose ASP.NET Core because I know that's what I have. And then based on that pipeline, it's going to create for me a YAML-based pipeline that looks like this, right? And we can go ahead and save it and run it. And hooray for that.
And now we're done.
Now we're done. It's created a build based off of YAML. Right?
Okay.
Now, remember I talked about the visual editor earlier, right? If you want to do everything in a manual way, you can use the visual editor. So the way that a build works in Azure Pipelines is it's basically a task runner, where it does one task after another task after another task after another task.
Okay.
And the way that you would customize it is by adding and removing different types of tasks. Right? So a lot of people ask, okay, now that we have these YAML-based builds, they're super cool, but is that a whole new build system from the old way that we used to do things, which is the visual editor?
Right.
And the answer is no, it's actually the exact same build engine.
It's like a preference between right-click or going to the command line. It's two different looks at the same thing.
Yes.
So what I change visually will be reflected in the YAML. But the nice thing about the YAML is that we can share that
Yes.
and check that in the source code itself, right? So we can reuse build workflows that we create.
YAML freaking rocks, right, for your build and your release pipelines. And just like you said, yes, you can share it. The thing that I love the most is you take this YAML file, it automatically gets checked into your repo right alongside your source code, right? The cool thing about that now is that your build pipeline, how it's configured, is now versioned right alongside your code.
So this means if I fork something that you've published to GitHub, for example, and I want to check it in on my own infrastructure and use that,
Yep.
I can check it in on my side and create that same build pipeline.
You
and
have the very same build pipeline that I'm using.
Nice.
And it's the coolest thing is you can go into my repo, my GitHub repo, or my Azure pipeline or Azure Repos repo, and you can find any point in time, do a get from that point in time, and it will have my build YAML file, right? So that will be that build for that particular point in
Right. So
time.
as you add new components or projects and extend your build out, if you have to, that gets versioned right along with the code.
Yes.
Nice.
Yes. So there's very, very exciting stuff. But a lot of times people tell me, well, trying to work in YAML, it's a little bit confusing. I don't know what the parameters are.
Right. You have to hit the space bar the exact number of times.
Because it's YAML, right?
It's YAML.
Be careful, don't tab, or you know, all hell's going to break loose. Yeah. So some of the things that I like to do is I like to start from my visual editor because it's visual. It's very easy to see.
Right.
Right. So let me show you what I mean. I can start from my visual editor, and then from there go and create a YAML build. So this is a build that I created last time, and we'll go ahead and edit it. And you'll be able to see that this is a visual editor with one task after another task after another. And I might have to do your trick of scrolling it the right way.
Clockwise mouse.
There you go.
Works every time.
Works every time. All right. So as you can see, it does one task after another, after another, after another. So what am I doing? I'm literally saying install Bower, run Bower, let's scan my code using white source, let's use .NET Core, do a restore, run my unit tests, go ahead and publish my test results. And since I'm using ARM templates, let's go ahead and copy those ARM templates as part of my build artifact as well. So now this build is going to kick off. It's going to run through all those tasks. And when it's done, in my build artifacts, it's going to store for me the zip file of my website, right, in binary form, ready to be deployed. And it will also have my ARM templates ready to be deployed.
So you have the infrastructure to run the code packaged with the code itself.
Yep.
Nice.
Each one of these tasks, there are parameters that you need to fill in, right? So install Bower, right, the working folder, et cetera, right? So you would need to come in here and just configure it however you need to.
So if I were, for example, using a global .NET Core tool that for some reason I wanted to run as a step in my process, I could easily come in here for the arguments on the command line and say .NET, run this tool, these are the arguments to pass.
Yes, exactly.
Fantastic.
Exactly. Yeah. So if you need to customize it, go ahead and add and remove your tasks. So if I click on the little plus next to the agent job, it will show me all the tasks that I have installed. So out of the box, there are hundreds of tasks for all sorts of languages, all sorts of platforms that you can just start using.
Wow, and these are even tasks that work with, looks like third-party build systems, and
Absolutely.
it's not just limited to the Azure ecosystem, in other words.
Yes. So I know this is a .NET show, and I'm a huge fan of .NET, but this build and release system literally doesn't care. Any language targeting, any platform.
Well, I think a lot of .NET developers are building web applications, right? So they've
Right.
run into the fact that some of the web front ends require Node, for example. So
Yep.
being able to have all pieces of that build orchestrated together is important.
Yeah. Any language, any platform. Now, if you want to do something that doesn't exist out of the box, like we come up with like a little bit over 100 tasks, go ahead and jump into the marketplace. And inside the marketplace, our partners have created, last time I checked, it was over 500 build and release tasks. There could be even more now.
Wow.
You can just download them and start using it. And if it doesn't exist in the marketplace and it doesn't come out of the box, you can write your own custom tasks. Custom tasks, I say this all the time, it's Node.js or it's PowerShell, which means if you can do it from the command line, you can get
You
this.
can do it here.
Yeah.
Yep.
Or if you call a REST API that does something, like literally you can make this build system do whatever you need it to do.
Very nice.
Yeah. The other thing is you can have your own build machine if you want, or you can use our hosted agents where we provide build machines for you up in the cloud. We have, out of the box, we have a couple different types of build agents that they can use. They can have Linux agents, Mac agents, and also, of course, Windows agents.
Okay.
So we're the only cloud vendor that will give you all three OSs. So no matter what type of app you're building, for whatever type of platform, you can use our hosted agents.
So I see there's a hosted Visual Studio 2017 and a hosted Windows container.
Yeah.
What would I use the Windows container for? Is that if I have specific dependencies I want to install on that container versus the host image, or how does that work?
Yeah, so every single type of agent that we have, every hosted agent that we have it's, once again, well, it's in docs.microsoft.com, and I'll provide the URL later. We provide a list of all the software that's installed on that particular hosted agent.
Okay.
So depending on what type of stuff you need, you can choose different types of agents.
And we can also have our own install steps in the build. So if we're starting with an agent that doesn't have a dependency, we can install that, right? So NuGet packages, if
Yes.
it's .NET, Node packages,
Node
if
packages,
it's Node.
NPM, whatever. Yep,
Great.
yep, you absolutely can.
Okay.
There are some software that absolutely requires you to click through, right, a UI or something like that.
Sure.
And, or you need special elevated privileges or whatever. That, if that's the case, then you're going to have to create your own agent, your own private agent. So creating a private agent is super, super easy to do. All you do is download the agent, run a script, and voila,
And you're done. Yeah.
It's literally that simple. It's ridiculously simple to do.
So if I have a completely custom build machine, for example, I could create a virtual machine, or potentially I might even still have one of those old physical servers
Sitting
in my
under your desk.
office, right?
Yep.
And what better use for that than as a build machine? So install the agent on it.
Yeah.
Even if I'm behind my corporate firewall, it, as I understand it, reaches out to Azure DevOps. It's not like there's an incoming connection that I need to open up ports or anything for, and it'll just run as is.
Yeah, so you make a really, really good point here, which is sometimes people don't want the builds to occur in the cloud, right? They want to have everything behind their firewall. And they always ask, hey, can I still use Azure pipelines? And the answer is yes. You'll have to create your own custom build agent, your own agent, and your agent has to sit behind your firewall, right? Like you said, nobody's drilling into your firewall, but that agent does need to be able to reach out and ping Azure pipelines.
Right.
Yep.
Very good.
So super powerful, super easy to use. Some other things that I wanted to show you, though, is once you create your build using the visual editor, it sure would be nice if we can just say, give me the YAML for this, right?
Right.
And of course you can by clicking on View
YAML.
And then from here, you'll be able to find all of the YAML that you can just go ahead and copy and then paste it directly into your YAML file, check it in, and right for that, you're done.
Nice.
You can even drill down to the individual steps and view the YAML for the individual steps as well.
I didn't know that.
Yeah. So a lot of times if I'm already have a YAML file and I just want to do something quick and dirty, but I can't remember what the parameter names are, I just throw it on the visual editor, find it, copy paste it, and right for that I'm done.
Right, so I could potentially fill out pretty much every parameter that's available, grab the YAML and see what the options are, and just edit that.
Yep.
Nice.
Yep. Some other things that I wanted to show you. You can have multiple agents, right? So right now we have one agent, but there's nothing stopping me from saying, you know what, let's go ahead and add another agent job. And now I can have another agent, and this time instead of a Windows machine, let's go ahead and use a Mac. Right, and then I can start adding my tasks.
This is nice, and we looked at a more complicated pipeline before that was building, I believe, on Mac to publish to the App Store for iOS, and then also on a Windows machine, and then also on a Linux machine.
Yeah, so you can make these builds be as simple or as complex as you need to. When I say complex, just like you said, we can have one build that builds like 40 different microservices on 3 different operating systems. This build can do whatever you need it to.
So I did notice you have this step here, publish test results. I know that's important for looking at the health of the build. We want to be able to run automated tests, but this will actually publish the results so they're integrated into my build dashboard.
Right.
And I can do that from .NET Core, I can do that from JavaScript testing. I just have to publish a special format, right?
Yes. So this is for all the unit tests inside of your project. So let's go ahead and grab a build that actually succeeded. And we can go into the summary. And just like you said, you can see all the tests that were run, which ones have passed, which ones have failed. This is just a little demo project, so I just threw together a couple of different tests. But if you go into the test tab itself, you'll be able to see in detail everything that's happened, right? So let's go ahead and pull this up. And once again, this is showing all my failed results. Let's do passed. And then you'll be able to see all of my unit tests that were run.
I like the badge that you get when everything succeeds, though.
That's customizable, too.
Nice.
So once again, you can drill into the individual tests. I wish I had a failed one here, because a nice thing, if you can find the test that failed, you can find the error message in the stack trace. You can see which work item it's attached to and things like that as well.
Now, can you have it auto-generate bugs if a test fails?
I know if a build fails, you can tell it to auto-generate the bug. I don't know if you can get the unit test to automatically create a bug for you. I don't think so, but I could be totally wrong.
But we will get a bug on bug failure. Someone can monitor that, go in, find out what's wrong, and issue the appropriate request.
Yep.
Okay.
All right. So we covered builds. We've covered builds is just basically a task runner. We've covered that the YAML builds are super cool, and they're not that daunting because you can just use the visual editor and then copy and paste, right?
Right.
Some other things that I wanted to point out is inside of VS Code, we have, let me see if I can actually demo this. Let me open up code really quickly. I have an extension installed. I don't think I have it installed on this machine, though. Anyway, there is an extension that you can go ahead and download that is called, I think, Azure Pipelines extension, that will give you IntelliSense for your YAML files.
Okay.
So that becomes super, super powerful, because now, instead of just guessing, you get IntelliSense, you get the little squigglies, you get autocomplete. So it makes the whole YAML editing process much, much nicer.
Now, is this IntelliSense for the YAML structure and format, or it actually understands some of the steps and can give you autocomplete for options for the steps?
It understands the steps and the auto-completion
Nice.
for the steps as well.
Very
So it's real IntelliSense.
You know, we used to talk about how Visual Studio and Visual Studio Code was an IDE versus an editor. I'll tell you what, with these extensions, though, Visual Studio Code can do quite a bit.
VS Code rocks, right? It does everything that you need it to do and nothing more. That's what I love about it. So I can install whatever extensions I need, and everything else I can just leave it out.
Nice.
Of course, I'm a huge fan of Visual Studio as well, because I do so much stuff in .NET, but VS Code freaking rocks. Yeah. The last thing that I wanted to show you is that there are a whole bunch of different ways that you can scaffold out these builds for a project. Because this right here, what I've just shown you so far for the build, is still kind of a pain in the butt, right? if I'm a developer, whether a .NET developer, Python developer, or whatever, I don't want to build these pipelines out, right?
No.
I'd rather have someone else build it for me, and then I just check in my code and have all the magic happen, and the build magically appears and releases, right?
That sounds good to me.
Yeah. So there is a tool using Yeoman that Donovan Brown created called YoTeam. And it is a scaffolding application for Azure pipelines. So let me show you what that looks like.
Okay.
All right. So let me go ahead and change up the screen res so everybody can actually see things a little bit easier. Let's do like 20 font. All right.
Boom.
All right. So I can do something like YoTeam, because I've already installed Yeoman. And once I do that, it's going to ask me which instance of Azure pipelines do you want to connect to.
Let me take a quick step back. For .NET developers who might not be familiar with Yeoman, is that just a package that I install to get up and running?
Yeah. It's just an NPM package that you install. And if you Google Yeoman, you'll find the instructions.
You'll get step-by-step, pull it down. And it's designed for generating templates for different types of projects.
Yeah, it's basically a scaffolding tool.
Okay.
Right.
Awesome.
So in this case, it's going to scaffold a full CI/CD pipeline for me in the language that I want to use.
Okay.
So I just typed YoTeam, and it's going to say, hey, which account do you want to connect to? And I'm going to connect to my Azure DevOps Demo A, because I've already done this before. Since I've done this before, it's also asking me for my personal access token, which is great, because I have no idea what it is. So I'm going to have to copy and paste it. And now it's going to show me all of the agents that I have, right? So let's build a .NET Core application.
Sure.
Let's go ahead and use our hosted VS 2017 agent.
Okay.
So we'll go ahead and select that. Now it's going to ask us what type of application do you want to create? A .NET Core, .NET Framework, Node, Java, or a PowerShell module. So of course, we're going to build a .NET Core. I'll select that. And what is your name of your application? We'll call this Test App 2. Hit Enter. What do you want to deploy this to?
Nice.
I want to deploy this to Azure App Service. Okay. Hit Enter. Now it's getting all of my subscriptions. And I have
Too many?
Yeah.
You have 2 subscriptions. Too many.
I have way too many subscriptions. But let me go ahead and use my demo subscription. And we'll go ahead and create.
And for those new to Azure, the subscription is where we send the bill, basically.
Right.
So it's what would be set up for the umbrella of your Azure account.
Yeah.
Yep.
So I walked through the wizard, and now it's creating for me a sample app in the language that I picked. Right. So the sample app is going to be a .NET Core sample app. And it's also creating for me, within my team project, everything that I need. Right. So including my build and my release pipeline. And once again, it's going to create a build and release pipeline that makes sense for the technologies that I picked when I walked through the wizard.
Okay.
Yeah. So once this is all done, what I'm going to have is I'm going to have, on my hard drive, I'm going to have source code for my sample app. And all I'll need to do is take that sample app and go ahead and push that back into the repo.
And then I can just start customizing it, load my own code into it.
So like it says, now all you have to do is push when you're ready. So let's go ahead and take a look at this, cd test app 2.
And when you say push when you're ready, pushing your code into the repo isn't just going to put your code in the repo. It's going to use that build definition and build it.
Yes, it's going to push it into the repo, and it's going to kick off a build. Then it's going to release the app all the way out into
So it's
Azure.
creating the actual Azure resources that are needed to host it as well.
Everything. So we start from nothing, right? So let's go ahead and push this so we can see what happens.
Okay.
So hooray for that. We just pushed our code. And let's jump into Azure DevOps and see what's going on. So we'll go ahead and look for Test App 2. We'll jump in there. And once we jump in here, let's go ahead and look at the repos, because here you can see we have our sample code, including ARM templates.
Huh.
And let's go ahead and jump into our builds.
And this will create the correct ARM templates based on what you selected. So if I say Kubernetes, for example, it's going to scaffold out the resources for a cluster the resources to build a Docker image.
Everything that you need. Right. So now it creates for me my build template. And it's going to kick off the build in a little bit, and it's going to send it through the build. After it builds, it'll send it through the release pipeline. So here's the release pipeline. And this release pipeline is kind of cool because this is a real release pipeline where I have my dev environment, a QA environment, and a production environment. And so then it releases it through the dev, QA, all the way out to production.
So just from that one git push, after everything builds, deploys, and is released, I can navigate to my app and see it up and running.
You can see it up and running. If we wait just like 10 more minutes, it
right,
will all
exactly.
be
It's got
done.
to.
Right. So of course, the $1,000,000 question is, this is great. It's all scaffolded out for me. How do I get my code in there?
Right.
So easy enough. We can go jump into, let's go into the repos. This, remember, is just a Git repo. So I can easily clone it onto my hard drive. Well, it's actually already cloned on my hard drive. Delete all the files on here except for the template folder because I want to keep those. That's my ARM templates. And then just copy my code directly in there, upload it, and right for that, I'm done.
Nice.
Another way that you can do this, I love showing this because it just shows how versatile this whole system is. If I look at my build, one of the first things that I do inside of my build is I get my sources.
And then you can change where you get your sources from.
I can change where I'm getting my sources. So if it's from GitHub, I can just go ahead and choose GitHub. So as a dev, you no longer have that excuse of, oh, it's such a pain to like create a CI/CD pipeline. Guess what? You can scaffold it out. And how long did it take me to scaffold it out? Maybe a minute, 2 minutes?
Yeah, it was less than a minute, I'm pretty sure.
Yeah.
I mean, most of it was us talking, looking at the
Right.
options on the screen. So.
Right. So I understand that right-click and publishing is so convenient. And I use it all the time, too, especially when I'm just starting out and I want to make sure my app is working. But as soon as I'm ready to check that code into source control, I go ahead and use YoTeam. I scaffold out a whole pipeline, because then it's ready to go, right? And as soon as someone else joins the team, guess what? The pipeline's already there. All we're doing is just checking code in and out. And it'll automatically get built. Tests will be run. Binaries will get picked up and deployed from dev, QA, all the way out into our production environment.
You know, this is one of the issues with having been a developer for as long as I have, because it's almost painful to hear that what used to take us weeks of blood, sweat, and tears to get done can now literally be done in seconds. What an amazing time to be a developer.
In seconds. I used to be a consultant when my whole job was to go to companies and they would pay me ridiculous amounts of dollars to create these build pipelines for them. And now, a couple seconds and you're done.
And I did make a joke about subscriptions being where to send the bill, but I'm going to re-emphasize all of this free.
Yes. All of this is free.
Wow.
So good stuff, good stuff. I really love this build system for the simple fact because it's so customizable and so flexible where you can make it do whatever you need to.
Right. Well, I like the fact that I'm able to add steps, remove steps, use build agents, and pretty much control my universe from a few simple commands or screens or parameters in a YAML file, and then it's all created for me. Pretty powerful.
So just remember, any language, any platform. I know we just showed .NET today because this is on .NET, but any language, any platform. Python, Node, Java. It literally doesn't matter. We can build anything, any language, any platform, in front of your firewall or behind your firewall. So all you devs out there, once again, go to dev.azure.com and start building out your pipelines.
Hey everyone, Donovan Brown here. Welcome to the DevOps for ASP.NET Developer Series. In this episode, we're going to focus on unit testing. Unit testing is critical to delivering high-quality code. Using Azure pipelines, you can run any unit testing framework during your build. The results of the build can be shown on your build summary and on team dashboards. Let's see how Abel and Jeremy add unit testing to their project.
Abel, I have a question for you.
Sure.
I found out after compiling my application, worked fine, ran it locally, deployed
your
it.
machine.
Yeah, worked on my machine. And we went through a few ways to get it actually deployed, which was great. Turns out my boss wasn't too happy because they said that I needed to focus in on testing.
Right.
And my first response wasn't testing for the QA team. And it turns out that there's probably more I can do as a developer, and we have this concept of unit tests.
Right.
That is actually supported as part of Azure DevOps.
Yes.
But before we even get into how it supports testing, I'd like to better understand what is the value and approach to unit testing.
Perfect.
For .NET Code.
I'm so glad we're talking about this because unit testing is one of those subjects that I'm really passionate about. I'm a huge fan of unit tests, but I have not always been a huge fan of unit tests. I used to hate unit tests. But the theory behind unit testing is every line of code that you write that does things, you should also have other lines of code that test it to make sure it does what it's supposed to do.
Okay.
Right. So think of like a calculator function like an add function. You pass in two variables and you add them together and you return back a value, right?
Right.
So that function right there is super easy to write a unit test for, right? Because you can say, okay, add 3 plus 2 and the answer better be 5. Or if I add -3 plus -7, it better be -10, right? So you can see how writing tests like that would be useful.
Okay.
Yeah. However,
It feels like a lot of work.
exactly, it totally is. And I wish I could pretend that it's just, oh, it's super easy to do, but it's not, it is more work. And when I first look at this, my first thought was, great, now you're asking me to write double the amount of code, right? First I have to write the implementation, then write the tests that test it, and the answer is yes. Although it's not quite double, I would say it's about a third amount of time that you take to implement, so about how long you have to write unit tests. But they're super, super valuable. And here's the thing, when you first write unit tests, it seems really silly. Why am I doing this? Why do I even care? How is this even helping me maintain quality, right?
Right.
The important thing to remember, though, is for us, developers, fixing bugs is not hard if we can reproduce the bug, if we know the bug is there. Then it's really not that hard. Set a breakpoint, game over, right? You just go in there, figure out what's wrong, and fix it.
Sure. If you can set a breakpoint. If it's running in production,
right.
That's not necessarily the case.
Right. But the big thing for us is, if I know the bug exists and I can reproduce the bug, I can fix it. That's just the way it is. But the problem is, a lot of times, think about when we're writing code, not when we first start out the project and it's tiny, but it's been running for a while, right? And somebody asks us to add some functionality. So we go in there, we add the functionality, hooray for that, we're awesome. And then we broke the app in 4 different places.
Right.
Has that ever happened?
Never in my career, but I have heard stories.
Clearly, I don't write bugs ever, so I've heard other people that happens to them.
My code always does what I tell it to.
Right. So that's really where unit testing comes in, right? Because if I have unit tests for all of my code that tests how my code should behave, and I go in there and add a new functionality, or I fix a bug or something like that, I can add that new functionality, I can break the app somewhere down the line, but my unit test will catch that, right? So immediately, I can find it, fix it, set a breakpoint, do whatever I need to, and I can quickly fix it. That's where the value comes in.
So it sounds to me like this, we could almost think of a submarine, right? That's underwater, and suddenly you get a hole, and the hole starts leaking, so that's a broken unit test. The unit tests are sort of an alerting system to tell us,
yes,
this change caused this problem. Maybe I increased pressure too much. I don't even know. I've never operated a submarine. But what's interesting to me is when I look at code, there's some code that is like a big hunk of metal all fused together.
Yes.
And it seems like that code would be tough to test.
Yes.
There's other code where you have firewalls and you have bulwarks and you have ways of partitioning the damage so that, let's say we spring a leak, it's compartmentalized in a certain area.
Yep.
So extending this, I'm just working through this in my head. It feels like taking on unit tests might also change the philosophy of how you build the code to make it more testable.
100% true, right? So In order to be able to write unit tests, your code needs to be testable. Right? You have to write your code in such a way that it's testable. Like you said, if you just have some big giant monolithic spaghettied code that's all intertwined together, how are you going to test that? That's impossible. Right? There's no way that you can possibly do that. So when I first started writing unit tests, well, my first reaction was, F this. It takes way too long, and it's such a pain in the butt, because it is a pain.
Right.
And I didn't really see the value until I really started using it. But once I started writing my tests, I realized that I now need to write my code in such a fashion that it's testable. So that did two things. Number one, it changed the way that I wrote my code. And number two, consequently, my code became much better quality because it's written in a testable fashion, so it's no longer spaghetti together.
So that actually is interesting too, because it feels like it could go almost back to the design and the specification piece of this too. Because when I think about writing tests, there's two approaches. There's you write a piece of code and you could test it.
Yeah.
Or maybe you get a story on your backlog,
yeah,
and you write a test for that story and you make sure the code does that.
Yes.
If someone tries to come to you and say, this function should return quickly,
yeah,
I don't know how to write a test for that.
Right.
But if someone says this function should return in less than 2 seconds,
yeah,
now that's more precise. So it feels like there should be a dialogue that goes on that says everything from the story down to the code should be testable, and if it's not, maybe there's something going on higher up the chain, so to speak.
Right. Absolutely. And I'm glad you brought that up, because like you said, there are a couple different ways to write your unit tests. When I first started writing unit tests, it was basically every method that I had, I would write a unit test for it. So as I wrote the method, I would quickly write a unit test that would test that specific method. But that kind of requires a lot of knowledge of what that method is going to do, and there's nothing wrong with it. It's a perfectly okay way to write your unit test. But then I ran into a friend of mine who showed me how to do behavioral-driven development. So first I was doing test-driven development, right, where you write your test first, and then you write your methods. But my biggest problem when I was doing just straight TDD was, as I was writing my test, I was like, I have no idea how to even begin to write my test, because I don't even know what the method's going to do. So then I would kind of go into the method and kind of jump back and forth, and that worked okay. But I like this idea of BDD, the behavioral-driven development, where you describe the behaviors, and it's pretty much exactly what you just said. Here we have a user story, and for this particular user story, these are all the behaviors that I want to happen. Right. Okay. Whether it needs to return back within 2 seconds, or maybe it's when the user clicks on the upload button, it's gonna take that data and put it into the database and in these tables, or whatever, right? So I mean, using behavioral-driven development, number one, your test becomes super readable, and the other thing is, wow, to me it's easier conceptually to figure out, okay, these are the tests that I need to write, and I do like the readability factor, and I'll show you that in a little bit.
Well, it sounds like some tests, because obviously I haven't been testing properly, but I have come across tests in the field. And you see this format of given something, when something happens, then expect a result. So I've heard of 2 different ways to approach. There's arrange, act, and assert, which feels like implementation detail of the test. And then there's given, when, then, which sounds like the expected behavior. Of the test. And it sounds like if you can write a test that says, given these, when this happens, then that happens, that can go all the way back up to the specification being written for the piece of code.
Absolutely. And then it becomes super, super powerful, right? Super easy. All of a sudden, your tests become very readable, and those can be used as part of your specs.
So would you say tests are a way to almost build trust in the code base as well? That if I'm in a large code base with 19 other developers, if I have tests, do I feel more confident about changing my code and checking it in because I know at least the tests that have been written have run?
Yes. So you can think of tests as, at this point in time, this is how my code is behaving, or this is how my code should behave. My code should pass all of those types of tests. So if I need to go in and add functionality or fix a bug, we're always afraid that we're going to mess something up, right? And the test gives us that peace of mind that even though I made these changes, the rest of the behavior still is the same. I think one of the best examples that I can think of in my career, I was given, this was quite a few years ago, but I was on a project and I wrote this data layer. This was before Entity Framework and all that nonsense. I wrote a data layer that connected up to SQL Server, right? And I embedded a bunch of SQL and all that nonsense. I wrote it really badly, but anyway, that's what I did. The client came back to me and said, "That's great, but we don't want to use SQL Server. We want to use MySQL." What could go wrong? It's all
Right.
SQL, right? So normally I would have panicked and freaked out and just said, there's no way I can do that. But luckily I wrote very, very extensive unit tests. So because of that, I just went in there, tore the code apart, ripped it into pieces, rewrote everything, and ran my unit tests. And immediately, like 5 of my tests broke. But I'm like, hooray for that, it broke, let me go and fix it. And then eventually everything turned green, and I was like, oh, let's see if this really works. And bam, it just worked, right? So it gives you that peace of mind to dive into your code, refactor, or add new functionality, or do whatever you need to. You have these tests that will kind of guarantee in a way that the quality is at a certain level, or the behavior is going to be what you think it's supposed to be.
So before we look at how we scale this, because obviously everyone running unit tests on their laptop is one thing, but how do you really know people have taken that step? I understand there's a difference between unit tests and things like integration tests,
right?
For example. So how would I test something that interacts with a database layer if I don't know that there's going to be a database available, for example?
That is a fantastic question. So the idea of unit test is you only want to test one unit of work. So if my unit of work includes hitting the database, getting data, bringing that data back, and then manipulating it in some way, right? That seems pretty common.
Sure.
My test should test the logic of manipulating that data. It shouldn't test the logic of, is my database query correct?
Right.
I'm going to assume that's correct. That's not the important part. The important part is my logic correct? Now, the reason why I want just that one unit of work is because when this test fails, now I'll know exactly where the test failed. Did it fail in the database query, or did it fail in my logic? Well, I know it failed in my logic and not the database query because I'm not testing that, right? So that's the theory behind you want to test one unit of work. The other thing, though, is when you're testing, for instance, and you have an outside dependency like a database, how are you supposed to test that? Right? Back in my day when we first started doing this, we would have a special test database,
right?
Special data, known set of data, right?
Sure.
So then before you ran the test, you need to make sure the data was in the right state. Then you would run the test, and then with the known set of data, it would return back the known set of data. And then after your test, you have to clean it up and revert it back to the same state.
Right.
Kind of a pain in the butt. It's very, very fragile.
Sounds like if you had 1,000 tests, that would take a really long time to set up and run and tear down too.
It would take for freaking ever, right? When you make a call to the database or make a call to a web service, number one, you have to have the database out there, or the web service out there, or the API sitting somewhere, right? You have to have the stuff there for you to actually test these outside systems. You can do that, but like you said, very slow, right? Number one, it's super, super slow. Number two, now we have no idea if it breaks. We don't know, is it breaking because the data's bad?
Right, is there a poor setup?
Yeah.
Right.
Or is it my logic? So we can have broken tests, red tests, and no clue, is it really the logic that's broken or the whole setup that's broken? And to make matters worse, what happens if you have more than one person trying to run these tests at the same time? They start walking on top of each other's data, then it turns into a giant cluster. Right?
Sure.
So to mitigate all of that, we want to do something called mocking, right? Where instead of making a call to the database, now I'm going to make a fake call to the database where I don't really go to the database, but I'll just return back my known set of data. So this way, I don't even have to have that database out there. I don't even have to have anything deployed. I don't have to have my web services, my API layer, or anything, right? Because I'm going to mock those calls out. So if the call is to return me the top 10 most frequented items in my catalog, instead of hitting a real database, I'll just be like, okay, this is the method I'm going to call, or this is the SQL method I'm going to call, and I'll just say return back this specific data. And I'll show you some examples of mocking as well. But mocking is extremely important, right? Any outside dependencies you want to be able to mock. You want your test to be able to run independently and run super, super fast. So,
And by mocking, we mean have a pretend implementation, not make fun of the database. You're a database.
right,
All right.
right.
Sounds good. Terrible joke. People call that dad humor. But let's talk about the fact that I'm sold now on unit tests.
Yeah.
I obviously can build them and run them here, but there's a component of Azure DevOps that also recognizes and integrates
Absolutely.
unit tests as well.
So Azure DevOps, you can do whatever types of unit tests you want, right? So you can write unit tests using MS Test, you can write unit tests using XUnit, NUnit. There's all sorts of different types of unit testing frameworks. And Azure DevOps supports them all. So why don't I jump in and kind of show you how you can set all that up.
Sounds great.
All right. So on my screen right now, I have some code for our Hotel 360 app. And this one here is the controller for the testimonials. So in a nutshell, if there's an API that I can run and hit that will get me all the testimonials for this particular hotel.
Okay.
So what it does is it hits my testimonial service and it calls the get testimonial method.
Okay.
Right. What's kind of cool is whoever wrote this code, they must have thought about, let's make this code testable. Good job. Even though you didn't write the test, you made your code testable, right?
Right.
So what they did was they created an interface, an customer testimonial interface. And if we look at this particular interface, it's pretty simple. It just says, I have one method that says get testimonial, right? So when I go ahead and write, and of course it's using dependency injection. The .NET Core framework is using dependency injection to put in the real testimonial service through this constructor. Right?
Okay.
So that's just .NET Core magic that just happens.
Configured up, passed in,
yeah.
We're good to go.
So when I write my test, easy enough to create a test project. Let's go ahead, you just right click it and say add a new project. And immediately you'll see in the wizard, it'll ask you, okay, what type of projects do you want to create? And of course I'm initializing everything. One of the things that it's going to have is different types of testing projects that you can use. So let me go ahead and go to .NET Core. And as you can see, we can do MS Tests, NUnit, and XUnit right out of the box.
Okay.
So I happen to write my test using XUnit. You don't have to. You can use any unit testing framework. I'm actually not super tied to any of them. They do all about the same stuff. There's a little bit of differences here and there, but at the end of the day, it's a unit test, right?
Okay.
So pick the unit testing framework that makes sense for you and your team. So if I look at my test is pretty simple. My idea is if I browse to the testimonial API, let's go ahead and return all the testimonials in a JSON format. So if you look at my index, that's exactly what it does, right? I hit this API and it's going to return me back all my testimonials.
Okay.
So when I write my unit test, first I create some fake data. I need a customer testimonial, which has a name and then the text. So I create my fake data. Then I'm going to mock out the testimonial service. So instead of having the real testimonial service that goes to our API layer, I'm going to mock this out, and I'm going to mock out the guest testimonial. I'm using MOQ, the library mock. There are a ton of different mocking frameworks as well that you can use. I don't care which one that you use.
I feel like if I've been writing tests all along, that would be my favorite framework.
since you know nothing about unit tests.
MOQ is pretty powerful in what
Pretty
it
powerful,
does.
pretty standard. Inside of MS Tests, there's a mocking framework as well, Microsoft Fakes. I'm kind of a huge fan of Fakes because they're super cool. Although I don't know if it works with .NET Core yet. I know that was on the backlog.
Yeah, that's a good question. I'm not sure either.
Yeah.
But it's really good for those really hairy classes to test that are static and not playing by the rules. It does a good job.
Yeah, the mocking framework with Fakes is freaking amazing, right? Because ultimately, no matter what mocking framework you use, what do you end up with? You have an interface, you implement that particular interface with a mock, and then you just fill out the method that you want and return back whatever data you want.
Right.
But you have to have interfaces, which means you have to go back in, refactor your code to use interfaces like our code right now. It's already refactored in a way that we're using interfaces. What's powerful about Microsoft Fakes is you don't need interfaces. You can literally mock out any object, any method, public, private, static, system, it doesn't matter, right? So it's super powerful and super useful. Like I said, I don't know if you can use it with .NET Core yet. I should have looked that up before we started. But it's a cool mocking framework. But anyway, I used MOQ. So I created my mock. And when they call get testimonial, I'm just going to return my fake customer testimonial.
Okay.
So then I instantiate my controller right here. And I pass in my mock.
Okay.
So now
that's that dependency injection.
Yeah.
And look at that. There's even comments that say arrange, act. And I bet there's going to be an assert.
Look at that. Look at that. There's an assert.
So the range is setting up the test.
Yep.
The act is executing the test.
Yep.
And the assert is checking for the desired result.
Yep. So in this case here, my act is I'm going to call my index, and I'm going to get a JSON result back. And now I'm going to, a couple things I'm going to do. The first thing that I want to do is I want to make sure that the get testimonial call, this method here, testimonial service.get testimonial, I want to make sure it actually got called.
Right.
So I'm checking, did it ever get called? Did it get called one time? Because I only want it to be called one time. So that's what my first assert is doing. And then my second assert is I want to make sure that it's going to return back the correct data, which is the fake customer testimonial.
Makes sense.
Right. So that right there is how you can write a particular unit test, right? So now I can check all this code in. During my build, I want to make sure we compile all of these unit tests and run these unit tests.
Okay.
So the way that we would end up doing that is, let's go ahead and jump back into our pipeline. Here is our pipeline build. Right. So this is pretty standard for a .NET Core application. The first thing that I do, I scan my source code using white source built for security violations or flaws or things like that. Then I'm going to use .NET Core SDK too.
Okay.
And I'm going to do a restore.
So all the dependencies get pulled down.
Yep, yep, yep. And then after I do a restore, I literally just call, and that's going to build my app as well, I'm literally just going to call .NET test.
Okay.
Right. So if you do everything through the command line, actually, I have the screen right here ready to go, right? So if you're doing everything through the command line, you can just say .NET test, and that will go ahead and build all of your tests and run all of your tests, right? So inside of Azure DevOps, we can just use the .NET task, and here we're going to say, let's go ahead and run test. The command we're going to run is test, and we're going to pass in the argument of -LTRX. So what that says is the output of my test, put it into a TRX format.
Okay.
The reason I want it in a TRX format is because once I have that, I can use the published test results, and it will publish that TRX file, and then I'll be able to see my test results in my build report.
Okay.
Right. So that's really all the magic that's there. I run a .NET test, make sure that I get the TRX file, and then let's go ahead and publish it using the publish task. So once we do that, we end up with a build. Let's go ahead and look at one of our builds and see what the build report looks like. We'll go ahead and jump in here. Let's go into our build summary. And you can see we ran some tests. 100% of them passed. And of course, that's because I'm barely running any tests at all. I have one test.
Right. Wow, 24 seconds to run your test. Can you speed that code up a little bit?
Actually, you can, right? So the first, the first test takes a really long time.
Because it's setting up the whole environment and getting it ready. And then but if you have 1,000, they're not all gonna take 24 seconds.
So you can run these tests in parallel as well.
Right.
Right. So that really speeds things up, especially if you have a really beefy build engine that has a lot of cores. Right, then you can just run everything in parallel and it goes super fast. So here's the interesting thing about how long do tests run. Unit tests are so important, especially in today's DevOpsy world, where we're continuously pushing code out into production. Right. So back in my day, how did we, super old, how did we find our bugs? Right. I never used to write unit tests because, like you, that's the QA's job. Right? So I would write my code, throw it over the wall, grab another user story. I'm done. Grab another user story, and I'm off to the races. Right? So I'm like, I'm awesome. I've closed out all these user stories, although I might have written a whole bunch of bugs. I'm not going to know that until QA finally finds it.
Right.
And when they do, I'll go and fix it. Right? Or maybe I'm off to another project, and some other poor fool has to fix my bugs for me.
Exactly.
The problem with that approach is for QA to find it, they have to run functional tests. And they have to run end-to-end functional tests to find any of the problems if it's buried way down deep, right? End-to-end functional testing, how long does that take?
Long time.
For freaking ever, right? Easily, you can do end-to-end functional testing for 2 weeks. Easily, you can do end-to-end functional testing for 3 months.
And by then, I've already forgotten the code that I wrote. So when they come to me with the defect, I'm like, who wrote this? Oh, that was me.
Oh. And then you look, you're like, what was I doing?
Right.
2 things happens usually, right? I look at my code and I'm like, who wrote this? Idiot. Oh, it's me. Or sometimes I'm like, oh, that code's beautiful. I'm amazing.
Right? That's usually what I end up with.
Of course, right? That's we don't write bugs. But so in a DevOps world where let's say our sprint's 2 weeks long, and we're pushing into production every 2 weeks, how are we going to maintain quality if our testing, end-to-end functional testing, takes 3 weeks to do? So every change that I have to do requires the QA to do the whole end-to-end testing again. How are they going to keep up? Right? They can't.
Right.
So how do we maintain quality in this DevOps world where we still can push code out really quickly? And the answer is we moved, well, if you look at what we've done with Azure DevOps, so the Azure DevOps product, so that team, we used to do end-to-end functional testing, and it would take close to 6 months to do full end-to-end testing. So we're shipping new code every 3 weeks. So clearly, something
that's not acceptable, right? Yeah.
So we started moving away from functional testing. Our first thought was, let's do automated UI testing. So we took all our functional testing. We spent $1 gajillion to have people write automated UI tests, and they did. And then we would run them. And 2 things happened. Number 1, it would take forever to run because automated UI testing.
Has to render the UI, parse the UI, exactly.
Yeah. The other thing is, anyone who's written automated UI tests knows that they are extremely fragile.
Right, you move the button, change the button name, add a new text box.
Super fragile, right? And to make matters worse, we always had those instances where you run the test and it would break, you run it again and it would work. Nothing has changed, right? I just ran the test 2 times. Ran it the 3rd time, it might work, it might not, who knows, right?
So you uncover quantum computing without realizing it.
Well, yes, sure. So it's, that had the result of we never had a full test run that was all green. They were always red.
And then you made exceptions, worked around them, patched it up, got it out the door.
Eventually, we just started ignoring those red tests
Right.
because it's like, oh, I'm sure it's just a fluke, right? And then you'd ignore it. So they basically turned useless for us. So we moved away from functional testing, whether it's by humans or automated UI, and then we moved our efforts more to the dev side, right? We shifted left. So now we're going to try to test everything using unit tests. Very, very detailed, very, very careful unit testing. Every single pull request that we do has to pass our tier 1 and tier 2 unit tests. So those are our fastest running unit tests.
Right.
So just to give you an idea what that looks like, check this out. This is my engineering dashboard for Azure DevOps. Of course, it's rendering right now. I need to find my pull request. Here we go. And we'll go ahead and jump into this live, and we'll see a pull request that's actually going on. Let's go ahead and just grab any one of these. Let's grab a green one. So here's a build, right? You do a pull request, it kicks off a build.
Completely automated.
Yep. If you look at our summary, and you look at our testing,
wow.
every single
74,000.
Yes. How do we maintain quality at a pace where we're pushing code into production once every 3 weeks? And what we don't usually tell people, but I guess I'll just tell the world now, we push bug fixes multiple times every single day. So how do you maintain quality when you're moving at that pace? The answer is every single developer check-in has to pass 74,000 unit tests.
It's like 74,000 QA bots checking off
Yes.
little pieces of code.
That's how important it is. And of course, all 74,000 ran in about 20 minutes.
Nice.
Right? And if you want to parallelize this even more, or you just even beefier machines, you can get that number way down as well.
So the only other thing I wanted to touch on is my understanding is that with these unit tests, because you're publishing them and Azure DevOps is aware of them, you can do creative things like automatically issue a ticket for me if one of my tests fails.
Yep.
And block my code from being pushed into the main branch.
Absolutely.
Because it's defective.
Yep, and that's exactly what we're doing with the Azure DevOps team as well. If my pull request, if the build breaks, that code, nobody even reviews it. It just automatically gets rejected. Your build needs to succeed. But our build is not just, it needs to compile, which is of course super important, but it needs to pass all 75,000 tests as well.
And you have different tiers of tests based on how complex they are, how long they take to run, and everything else. That's amazing.
So I don't want to say that functional testing is irrelevant.
Right.
Because it's not. It's still important. You still need eyeballs on the product. You still need to do some click testing of the UI itself. Whether it's automated or human or whatever. I mean, you still need that. But the big bulk of your testing effort needs to be on the developers to write good unit tests, and not just bogus tests, right? I can write 100 tests that gives me 100% code coverage that doesn't assert a thing.
Right.
Right. So your tests have to be good. So to make sure that our quality is good, every pull request, well, you have to have reviewers, right? When you review it, not only do we review, let's say you do submit a pull request, I'm not only going to review your code, I'm going to review your tests as well to make sure your tests are good. Because when the product breaks, I don't want to be if I'm on call, I don't want to be called to fix your bugs that's running in production, right? So quality needs to be maintained everywhere.
And that actually draws to mind the kind of last piece of the puzzle for me, is that in a code base with well-written tests, I don't even need to go to a developer wiki to understand how to use the code.
Yeah.
The tests not only explain what the code's supposed to do, but they demonstrate how to use the code. And as a developer coming onto a project, that lets me onboard more quickly as well.
Yeah, and that's one of the reasons why I love the whole behavioral-driven development, right? Because your tests become so readable that you're like, oh, I know what's going on. So let me give a quick example of that as well. If I look at some code that I wrote for Donovan, I have a whole bunch of tests. Of course, the font is really tiny, so you'll have to jump in here. But one of the
just adjust my glasses. Okay, zoom in.
So I wrote all these tests, and I wanted to make them very readable, so anybody could just look at it and be like, oh, for instance, manage headshots for advocates. From the view advocates, I add a headshot by clicking on it. All right. So if I jump into my code, that's literally what it's doing. It's just testing to make sure that when I click the upload of a headshot, that it actually does what it's supposed to do. If I look at my code, let's go ahead and jump in here. What it's doing here is basically I get the file that gets uploaded, right? And then from there, I'm going to upload it into my database. But first thing that I'm going to do is I'm going to check, did they actually include a file or not? If they didn't, route it to an error page. And if they did, well, grab it in a memory stream, wrap it in my object, then push it into my repository.
Nice.
So then my unit test needs to test this, right? It needs to test that logic. So that's what it does. But now my tests become very, very readable. If I enter an empty file list, well, make sure I write back to the view or something like this, right? So that kind of goes back to your whole thing of, even if I'm jumping into a new project or I'm jumping into sections of code that I haven't looked at before, I can look at these tests to help me figure out what is my code actually doing.
I'm sold.
All right.
I'm going to go write some unit tests.
Let's go write some unit tests.
All right. Awesome.
Super, super important. I know they're a pain in the butt, but it's kind of like, would you build a house without putting down a concrete foundation first? You could. You build your house much faster. Might fall over eventually.
Right.
Right. So
pay for it in the end.
Yeah. Pay for it in the beginning, not the end.
Right. Sounds great. Thank you so much.
Absolutely. Thanks, man.
Hi, I'm Jeremy Lickness. You've watched another episode of On.net. Thank you for joining us. Be sure to like and subscribe so that you don't miss a show. And if you're interested in more shows, check out the link right here. Thanks.
Hey everyone, Donovan Brown here. Welcome to the DevOps for ASP.NET Developer Series. In this episode, we're going to focus on advanced release topics. With release, you can do more than just automate the deployment of your code. You can also run integration tests, security scans, or deploy your containers. Let's see how Abel and Jeremy add these advanced features for their pipeline.
All right, Abel, I'm super excited. After our last talk about unit tests, I integrated some unit tests, updated them, actually found some defects that wouldn't have been caught till later. So the code's built.
Yeah.
It's pristine, it's beautiful, but it's not running anywhere. I know it's good, I know it compiles, I know my tests run. What's the next step?
You need a deployment pipeline, right? You need to be able to deploy your code into production somewhere or into someplace.
Sure.
So luckily for you, Azure DevOps is here to help you. You can use Azure DevOps to deploy your code anywhere.
Anywhere.
Into Azure, of course.
Okay.
You can deploy your code behind your firewall, in front of your firewall, someone else's cloud. Don't use someone else, use our cloud. But the tooling literally doesn't care, right? We'll let you deploy anywhere, however you want, for any language as well, not just for .NET.
Okay.
Yeah. So if we jump to my screen, what you see here is my deployment pipeline. So when you set these things up, what you need to do is first you need to decide what stages do I have, right? So in this case here, I have a dev stage, a QA stage, and a prod stage. Pretty simple.
Okay.
Right. So after you figure out what stages you have, then you can go into each stage, and from here, you start adding the tasks that you want to run to deploy your application into that particular stage.
So stage is going to be, for example, I'm doing QA testing. I might actually have a staging environment that is a QA-like environment that has mirrored production code and out to production and anything in between that I might want. Okay, makes sense.
Whatever you want. And actually, if you think about it, a stage doesn't even have to necessarily correlate to an environment.
Okay.
Right? A stage is just basically a set of steps that will happen at that particular stage, and you have approvers before and after each stage as well.
Okay.
So in theory, it doesn't even have to be an environment, but it kind of makes sense.
So if I go back to, I've done web development for years, but I also did a little bit of actual desktop application. So a stage might be packaging the application into a deployment package, and then I might have another stage to test the install, for example.
Yes, exactly.
Sounds good.
So your imagination is the limit of how you want to distribute these stages. So you figure out what your stages are, then you figure out what are the tasks that are going to run. Right. So this is just like the build. It's the task engine, does one task after another after another. So in my case, I'm going to go ahead and use an ARM template to deploy my ARM template into Azure, my environment into Azure.
So that's an Azure Resource Management template. Describes infrastructure basically through declarative code.
Yeah, infrastructure as code.
Yes.
So in my ARM template, I basically described exactly how I want my infrastructure to look like. And then in this particular stage, that first step is it takes that ARM template, goes to Azure, and creates for me that exact environment that's described in my ARM template. Or if it already exists, it doesn't do a thing. Or if it exists, but it looks a little bit different, it will tweak it so it looks exactly like how my ARM template describes it.
Okay, cool. So we've passed a set of instructions to the 3D printer, and it's 3D printed some cloud assets for us.
There you go. Perfect.
Okay, like a web server, for example, or a database.
Yep.
Okay.
Yep.
Sounds
Very
good.
Cool. And then once I do that, then I have a task that will take my application, which is zipped up in a zip file, and let's go ahead and deploy that into my app service or wherever I want to deploy it to.
Okay, so this one's really simple then. It's create something to run my web app, and then deploy my web app into it.
Deploy my web app into it.
Okay.
Right. So it's super simple to do. Out of the box, you get hundreds of tasks that you can just start using. Right. And you'll start seeing, man, this is for like all languages, all different platforms, whether it's the Apple App Store, Amazon Cloud, of course Azure stuff. There's going to be a ton of Azure stuff. So basically anything you want to do with Azure is already pre-built and you're ready just to rock and roll.
Okay.
If you want to do something that doesn't exist out of the box, jump into our marketplace. So our marketplace now has, I think, over 900 tasks, like build and release tasks that our partners have created. So those you can just download and start using. And therefore, if you scroll through this list, it's massive, right? And it's just for all sorts of stuff. Whatever you can think of, it probably is out there.
Now, if there's something that I need to have done deployment-wise that there's not something in the marketplace for? Is that something I can build myself in some way?
Absolutely. You can write your own custom tasks as well.
Okay.
So a custom task is PowerShell or Node,
All right.
which means whether you're on a Windows system or a Linux or Mac OS system, it doesn't matter, right? You'll be able to write a task that does whatever you need it to do. And if you really think about it, if it's Node or PowerShell, I mean, basically anything from the command line, I can write a script that does it, right? So it becomes, it's really easy to get what you want done. So what I always tell people, whether it's for your build or whether it's for your deployment, if you don't know how to set up the pipeline, ask yourself, how would I do this from the command line? And what are the steps that I'm going to do? Because most likely you'll find a corresponding task that does those steps, and if you don't have that task, you can write one.
Okay.
Right. So
Makes sense.
easy enough to customize this and make this do whatever you need it to do.
Sure.
All right, so we've defined what our environments are going to be.
Okay.
We've gone into each one of our environments and defined what are the tasks that are going to actually run. If you look in my QA environment, I think I do some extra stuff, right? I do some load testing as well.
Okay,
in my
very
QA.
cool.
So the idea is deployment application, let's pound some load, let's see if it's still working or not, right? You can do your automated UI testing here or do whatever you need to.
That's a relief because I don't want to run load tests manually every time we deploy.
Right.
So to be able to automate that is a relief.
Right. So we've created our environments, we've created our tasks that will run in each of the environments. The other thing that you need to decide is where are your artifacts that you want to deploy? Where are those coming from? Right, so these are going to be your build artifacts. If we go ahead and click on Add, you'll be able to see.
So for a very scientific definition of build artifact, that's the stuff that makes my application run.
Yeah.
So what comes out of a build,
Yeah.
basically?
So if you think about what does come out of a build, right? Usually it's going to be my binaries. There might be my ARM templates.
Assets like images.
Yeah. Images, fonts, whatever, right? It's just whatever it's just the output of your build.
Okay.
So the output of your build is stored back into Azure or Azure DevOps. It's actually blob storage, but it's all we need to know is it's held inside of Azure DevOps. And from there, if I select a build, I'm able to pick which project and which build I want to use, right? And then it will go ahead and grab that particular asset as my build artifact. And I can grab build artifacts from any build that I have, or I can grab build artifacts from an Azure repo, or from GitHub, or from if I'm using TFVC.
Now, when you tell it to grab an artifact, does that mean it's automatically triggered when that artifact is created?
That's a very, very good question. If you click right here, this will help you enable continuous deployment or not.
Okay.
So what that means is if the build is successful, let's automatically deploy this.
Okay, so it can either be a manual or an automated step.
Yeah.
Okay.
So if I make it manual, if I disable this, then the build will succeed, but nothing will happen. But I'll have to come and actually trigger this release, and it will grab the latest build, and so on and so forth.
Okay.
And actually, when you trigger a build manually, you get to select which build do I want to use. Do I want to use the very latest, or do I want to use like a one from the past or something like that as well?
Okay.
Right. So we've defined our stages. We defined the tasks that we want to run for each stage. We've defined what our build artifacts are. And you can have, I'm only using one build artifacts, but you can have more than one.
Okay.
Now you get to decide who are the approvers before and after each environment.
Okay, that makes sense.
So what I've done is I don't have an approver for a pre-deployment approver for my dev environment.
Just send it out there.
Blast
We're
it into
just
dev.
testing how it runs in the wild,
Yep.
basically.
Yeah.
Yep.
It's dev. Who cares about
Who
dev?
cares?
Yeah, it'll be fine. Right. All right. So after it's done, I sit here. I do have a post-deployment approver. I'm waiting for someone to actually say, you know what, dev looks good. Let's go ahead and dump it to QA.
Okay.
I've also added a pre-deployment approver for my QA environment. Because maybe they're in the middle of testing, they're not going to be happy if I just blast new code right in the middle of their testing.
Sure.
Right now.
So from our perspective,
Yeah.
looks good. We open the gate.
Yep.
From their perspective, we may need to wait a couple days before we receive it. Okay.
So I'm giving them the option of saying, now we're ready. And then it'll go, the bits will immediately flow. right?
Okay.
And I also have a post-deployment approver as well. So the post-deployment approver is kind of cool because when your deployment runs, you get the choice of saying, this is great, go ahead and pass it on through, and it flows on to the next environment, right? And then the next environment, if you have a pre-deployment approver, you have the ability to approve the deployment, but schedule when you want the deployment to happen as well.
Okay.
So you can say, yes, I approve it to be deployed into QA, and let's go ahead and do it immediately, right? Or you can say, I do approve it, but let's wait until 2 in the morning or something like that.
Sure.
So you have the ability to do that as well. So basically, that right there in a nutshell is your deployment pipeline. Define what your stages are, define what tasks will run inside of each stage, and then go ahead and define your approvers before and after each stage as well.
So it makes sense to me deploying code through this pipeline.
Yep.
You have code package, it's a DLL, a zip file, whatever.
Mm-hmm.
I know from experience working with relational databases that you can have either schema changes to the database or even data that you need to populate.
Yes.
Can that be part of this pipeline?
Absolutely. I'm glad you brought that up because that is vital, right? Database DevOps.
Say that 5 times real fast. Database DevOps, database DevOps.
Database DevOps.
Okay.
Like that. So database DevOps is absolutely vital in this DevOps world, right? Once again, we're trying to continuously deliver value. So as soon as we can, we want to deliver value to our end users. We have to include databases as part of that as well. So there are a couple different tools that you can use that helps enable database DevOps, right? Basically, you have a tool that encapsulates your schema and the changes that you make to your schema. So you can use SSDT, SQL Server Data Tools, I think. That is Microsoft's tool that literally encapsulates the schema of your database. You make a change to it, and it changes the SSDT project. Part of the build steps, it's really cool because an SSDT project is just part of your Visual Studio solution. Part of your build steps, when it builds an SSDT project, it creates for you something called a DAC pack, right? So think of a DAC pack as the schema of your database that's been flattened and stuck into an XML file.
Okay.
It's not quite that, but close enough,
I'm
right?
just excited that we still get to work with XML.
Old school.
Yeah.
So with the DAC pack, you can do schema compares because the entire schema is encapsulated, right?
Right.
So you can say, what is the difference between the schema that's described in my DAC pack versus the schema that's described in my dev database? And it will say, these things are different, and these are the scripts that you need to run to change your dev database so it looks exactly like your schema in your DAC pack. And then there's another task that will just go ahead and run that script so it changes your database schema to match what you think it is, right? Or what it should be.
So the last time I had to do this manually was 10 years ago, writing a script to automate the comparisons. Sounds like the tooling has come a long, long ways.
The tooling has come so far, right? There's another set of tools that I really like using as well, and I'll give a shout out to our partners at Redgate.
Sure.
So Redgate has some database tools that are absolutely fantastic as well. So SSDT is basically state-based, right? So this is the state of your database, what it should be, and here are and I'll auto-gen for you the scripts that will change it from this particular state to the state that it needs to be at.
Okay.
So at Redgate, it does have state-based as well, but they also do versioning, right? From one version to the next to the next. And I really like that because you have super fine-grained control over exactly what happens. So basically, it's like, okay, I add a column. So from version 0, there'll be no column. From version 1 now of my database, I'm going to add a column. And so these are the scripts I have to run that goes from version 1 to version 2. Right?
Okay.
The nice thing about that is now I can say, before I go from version 1 to version 2, let's go ahead and take this data, move it into a temporary table, move it into the column. Right? So now you can.
Now you can stage your actual data and schema kind of changes together.
You have more control over exactly how your data will behave as part of that.
Or we can just change to a NoSQL database and not have to deal with schema changes.
Yes, that would be fantastic as well.
But we lose relationships.
Yeah, and we have a ton of old projects, right? What are you going to do? Are you
exactly.
really going to change out the entire database?
You can't ignore that world. I was being a little tongue-in-cheek there.
Yeah.
But
no, I do love NoSQL as well. But sometimes you really do need the relationships as well, too.
Well, a lot of
So it
times
depends.
projects will have both, right? They'll
Yep.
have a SQL aspect for what makes sense for that, and then a NoSQL aspect. So.
Yep.
But it's good to know that that can all go as part of this pipeline.
Yeah.
Now, you showed me you can just keep kind of the end of the gate open, or you can have like this manual step. Is there any way to automate approvals?
Actually, you absolutely can. We have something called automated approval gates as well.
Okay.
So before and after each environment, You can use these automated approval gates, which uses automation and AI to help you decide should this gate pass or fail.
Okay.
So to give you a quick example, let's go ahead and jump and look and see what that looks like. Out of the box, you get, I think, 5 different gates that you can just start using.
Okay.
So we'll work from the ground up, from the bottom up. The first one is the security compliance assessment gate. And this is super cool, right? It uses your security and compliance assessment for your Azure resource group to help determine if your gate should pass or fail. So
wow.
If somebody tweaked my ARM template and did something bad, this will catch it and be like, no, it's not passing our security compliance rules. Right?
Nice.
Yep. So another thing that you can do is you can do a query for work item gate. So this gate uses a work item query to help you determine if the gate should pass or fail.
Okay, so if I don't have certain stories that are marked complete, don't deploy it.
Don't deploy it. Yep.
Okay.
So one of the ways that we use it internally with the Azure DevOps teams is we look for blocking bugs.
Okay.
If there are any blocking bugs out there in the system, block, just, you know what, fail it, stop it.
Right.
So our deployment is pretty massive, right? It's Azure DevOps, the product, it's a global system. So,
sure.
The deployment actually takes an entire week to go from I press the button into the entire world. At any point in time, if we need to block that, we don't have to like find some special place and right click and do what, no, we just create a blocking bug and bam, it just stops it immediately.
So my question there though is if Azure DevOps is using Azure DevOps for Azure DevOps, which came first, Azure DevOps or Azure DevOps?
Azure DevOps.
Okay, good. Glad you cleared that up.
It's even better because everything is hosted in Azure as well, right?
Right.
Including the code that was written for Azure. It's so Inception, it makes my head hurt.
Well, I think this is important for people to know and understand, though, is that, you know, it's kind of almost derogatory sounding term when you say dog fooding, like you have to eat the dog food. But we use our own tools. We're not just presenting a service and then in the back end not following unit testing, not doing continuous deployment. Yeah. And that probably gives us unique insights into what the challenges are of doing this at scale.
Yeah, we literally use this every single day to not only build Azure DevOps, but to deploy Azure DevOps as well. What's kind of nice is we get to use ourselves, our engineering team, as our first line of testers, right? So the first thing that we do when we're ready for a new release is we release it internally to us.
Right.
And then we sit there for like 48 hours and we're all using it in our day-to-day life. And this is what we use to manage all of our work. And if we run into bugs or if the performance is down, we're using telemetry for everything. We're gathering telemetry. So if the telemetry is off or whatever, bam, it will just automatically stop as well.
Nice.
So that of course goes up to my next gate as well, which is the query for Azure Monitor alerts, which uses Azure monitoring to help you determine if a gate should pass or fail.
So if I suddenly have an endpoint that's crashing or responding slowly, or I can set actual business metrics as part of my automation.
Yes, you can say, you know what, if the response time is more than XYZ, then throw alerts. And if there are enough alerts, we're going to block this because the performance is just too bad.
Got it.
Right. Very, very powerful. So the last two gate is the invoke REST API and the invoke Azure Functions. So this is the extensibility point. You can write an Azure function or a REST API that will get called by the gate, which means this is just custom code, right?
So that pretty much opens it up to anything.
Anything.
If I can write a piece of code that responds to a REST endpoint, I can create a custom gate.
Yep. So 2 gates that I've written, right? Just right off the bat, 2 gates that I've written. I was at a hospital that had a horrible rule. Well, for whatever reasons, they have interesting rules. It's healthcare. You literally could not deploy into production without a document that was signed, uploaded to their DocuSign server.
Okay.
So this became a bottleneck in the deployment. Because first we have to track down the doctor and be like, dude, you need to sign this paper, and then you need to upload it, and then when it's uploaded, it needs to be verified by somebody, and then it can finally move on. And then sometimes people didn't check, right? They just said, F that, I'm sick of waiting, just pump it on through. And then you get in a huge amount of trouble once like HIPAA or whatever else becomes involved. But the big thing was it was just a bottleneck. So what I did was I created an Azure function that checked DocuSign and said, hey, is this specific document signed for this particular release? If it has been, let's go ahead and pass it. And if you look at it, so I deployed into QA, testers looked at it, everything looks good, they approved it. And once they approved it, my automated gate kicks on. So
Oh,
now
look at
I'm
that.
checking. So when you create a gate, you set up the polling frequency for your gate, and you also set how long do you want the gate to run until it times out. So I basically said, well, this is demo code. So I said run for every 5 minutes, and then let's run for 24 hours.
Okay.
But you can really tweak that to whatever you need it to be. So deployed into QA. QA tested it, looks good, they approved it. I immediately checked DocuSign. Has it been signed yet? Nope. Another 5 minutes later, has it been signed yet? Nope. Another 5 minutes, has it been signed yet? Yes, so great.
And then opened it up. That's amazing.
So this is just code, so you can literally make it do anything. So I was at another client where they're like, okay, Azure monitoring, that's great, but we're all on-prem and we're using Dynatrace. So can we use Dynatrace to help us determine if the gate should pass or fail? And I was like, of course you can. I didn't know, but it's code, right?
Right.
You can make code do anything. Dynatrace has a great set of APIs, so literally, once again, I deploy into staging, and after I deployed into staging, I run a whole series of load tests as well. And so Dynatrace is collecting information in the background. And as they're gathering up all of their telemetry, when I hit my gate, now I start asking Dynatrace,
Are we good?
given these parameters that I want tracked, are we good? And they told me, no, you're not. Your response time is way too slow. Bad code never reaches production. Right? So you can make these gates literally do whatever you want. If you go to the marketplace, you can see where our partners have created automatic gates as well that you can just download and start using yourself.
Now, when I hear the announcement that if I have open source and GitHub, I can use Azure pipelines, is this functionality available to me?
Absolutely. Yes, 100%.
So I can build gates and automate them and do all of that with my open source projects
All of
using.
your open source, and it's super, super easy to do. And you know what? We should actually have an episode where we do that. Super easy.
I think you just signed us up for
Another one more, right? We thought
Yeah.
we were getting close. But yeah, it's super, super easy to do. It's literally just like you need to install the Azure Pipelines extension for GitHub. And then from there, you select which repo you want, and then you're in business.
Nice.
Then you drop into this UI, and away you go.
That's great.
Yeah. The other thing that I wanted to show you, the last thing that I wanted to show you is you can make these pipelines as complicated or as simple as you want them to be, right? So the first pipeline that we showed is pretty simple. We're just deploying the web front end.
Boom, boom, boom. Yep.
But remember, the Hotel 360 app is a lot more complex than just a web front end. You've got a web front end that's a .NET Core app, and then you have an API layer as well that needs to run inside of a Kubernetes cluster. And
Sure.
there's also a mobile portion of that as well.
Right.
So you can create, and once again, you don't have to do it this way, but you have the possibility of creating one pipeline that does everything for you. So here's my one release pipeline that's actually 3 parallel pipelines. One for my web front end, we've already seen exactly what it does. Another for my API layer, where I'm deploying into a Kubernetes cluster. Right? So
Okay.
I'm using Helm to deploy my Helm application into a Kubernetes cluster. And then finally, I also have my mobile portion where I use App Center to deploy to my alpha testers, beta testers, and eventually all the way out even into the store itself. Oops, wrong test, here we go. Right, all the way into the Apple App Store itself.
Nice.
So these pipelines, all of our demos, we show just like plain simple demos, but you can make these pipelines literally do anything that you need to, in front of your firewall, behind your firewall. So a lot of times people ask me, how do you deploy behind your firewall, behind my firewall, right? You need to install our agent behind your firewall. So this agent, it needs to be able to see, this agent needs to be able to reach out to Azure DevOps, the product, and it needs to be able to reach whatever machines that it's deploying to.
Right.
And if you wanted to, you can install an agent onto each machine that you want to deploy to, or you can have it on a proxy machine that just deploys onto those machines.
But that's important to note because it reaches out. So it goes out and asks Azure
Yeah.
for the information. So you don't have to do anything funny with the firewall to open incoming requests.
Correct.
You're not exposing it.
Exactly. You do not need to open up your firewall, which is huge, right? So it just reaches out. Installing this is super, super easy. And I know we say that all the time, but literally, you just go into your organizational settings. And from here, let's go into our agent pools. And you'll see inside of the agent pools, it's going to give you a download agent link. And if I click on that, You download this, and depending on whether this is going to be a Windows machine or a Mac machine or whatever, you just run the script.
Nice.
And hooray for that, you're done. That's literally it. Well, you answer a couple questions and then you're done.
Right.
Right. So it's super, super easy to do. In front of your firewall, behind your firewall. If you're going into the cloud, you don't even need to have your own agent. You can just use our hosted agents as well.
Right. So we have hosted agents, but in the case I was at a previous company that had a dedicated build box. They spent the money on it, wanted to use it. So we orchestrated everything in the cloud, but the actual build took place on this one machine. So we were able to utilize the resource, but still take advantage of the flexibility.
Absolutely. Yep.
Very nice. That is incredible. Thank you so much for showing me Azure Pipelines. It looks like it's a piece of flexible technology that sort of has all the moving pieces someone would need. So I'm glad I was able to learn about it.
Awesome.
Hi, I'm Jeremy Lickness. You've watched another episode of On.net. Thank you for joining us. Be sure to like and subscribe so that you don't miss a show. And if you're interested in more shows, check out the link right here. Thanks.
Hey everyone, Donovan Brown here. Welcome to the DevOps for ASP.NET Developer Series. Getting started with DevOps can be intimidating. Luckily, there are many options to help you kickstart your DevOps transformation. You can use the Azure Pipeline templates, Azure DevOps projects from the portal, and even open source tools created by the community like YoTeam. Let's see how to use some of these with Abel and Jeremy.
Good to see you again, Abel.
Hey, how's it going?
It's going well. So I understand that you have another powerful tool in your special box of tools for DevOps that is going to make a lot of developers' lives easier.
Yeah, so the whole deal is creating these CI/CD pipelines are kind of a pain in the butt, right?
Right.
It's always much easier if you actually have a pipeline to work from and then customize it as opposed to starting completely from scratch. It's just much easier to do that.
Sure.
And there are a couple different tools that we can use that will help us either scaffold out or template out the pipeline for us beforehand, right? So that saves us a ton of time. And I know we've showed this a little bit in some of the earlier videos, but I really kind of want to do a deep dive and walk through exactly how to do all this. And there are basically there are two ways that I want to show. One of them is from the Azure portal, and one is using an open source tool.
Okay, cool. So it's if I'm a web kind of right-click type person, we can do the portal.
Yeah.
If I'm a command line person, I can go to the open source tooling and jump on the command line.
Absolutely, absolutely. So the name of the game, right, is we start from nothing at all. We have absolutely nothing, no infrastructure in Azure, nothing in Azure DevOps. We don't even have source code yet. And we want to fast track and create a pipeline.
Okay.
So let's go ahead and jump onto my screen. All right, so we're starting from the portal, right? And from the portal, what we're going to do is we're going to create a brand new resource. And the type of resource that we're going to go ahead and create is going to be an Azure DevOps project.
Okay.
Which is a very confusing name, right? Because we have Azure DevOps, the product, which used to be VSTS. And then we have these Azure DevOps projects, which really aren't exactly the same thing.
Okay. I'll take your word for it.
Yeah. So Azure DevOps, the product, is the all-up DevOps tooling. Right?
Okay.
And the Azure DevOps projects from the portal, this is the scaffolding tool that will build us out a CI/CD pipeline, give us sample code, and also deploy infrastructure for us all the way out into Azure.
So we've basically got a bunch of options with Azure DevOps.
Yep.
Going into the portal, the Azure DevOps project is a Kickstarter, basically. It's going to say, you have all these moving pieces, but here's an entry point to get started with those moving pieces.
Yes.
Okay,
Yep,
I think I'm following.
All right, so we're from the portal right now. We're going to create a brand new DevOps project. So at this moment, we have no source code. We have no project inside of the Azure DevOps, the product. And we have no infrastructure deployed out into Azure.
Okay.
So let's go ahead and create a DevOps project. And the first thing it's going to ask us is, what language do you want to use, right? you remember I always say any language, any platform, blah, 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 all that nonsense? Well, we really, really mean it, right? Because any language, whether it's .NET, Node, PHP, Java, we can use a static website, Python, Ruby, Go, C, or you can even bring
There's
your own
still
code.
people building projects in C.
Yes, absolutely.
That's
there
awesome.
still are. All right, so for this demo, I'm just going to go ahead and choose Node just because it's what I want to do right now. And I'll go ahead and click Next. Now it's going to ask me what type of framework do you want to use for Node? Do you want to use Sails, Express? I'm just going to say a simple Node.js application. It can be an IoT application. Do you want to add a database? In this case, no, I don't. I'm just going to go ahead and select Next. And now it's going to ask me, what infrastructure up in Azure do you want to deploy this application?
Okay.
So I've already said I want a Node.js application, web app, and I want to deploy this somewhere in Azure. Where do you want to deploy this into? So our choice is app service, right? A Kubernetes cluster, or app service using a container, or into a function.
Okay, so we can go serverless right from this template too.
We can. We can.
Awesome.
So just to make this a little bit more complex, because it's more fun that way,
Sure.
let's go ahead and deploy into
Do the cluster, yes.
Yeah, we'll deploy
Kubernetes.
into a Kubernetes service. And we'll go ahead and click on Next. So now it's going to ask us, OK, which instance of Azure DevOps, the product, do you want to build out the pipeline in? So I'm going to go ahead and choose my demo account. And I have way too many accounts. So here is my Azure DevOps Demo A. And we will call this on .NET Scaffold. And we'll call our cluster. And we'll deploy this in the east. That's fine. We'll click on Done. And yeah, that's all we need to do.
And that's it. It's going out and, oh.
Almost there. Almost there. Right. So what is it doing? It's actually doing quite a few different things right now. First, it's going to go ahead and create for us a team project inside of Azure DevOps, the product.
Okay.
Then it's going to load sample code in the language that we picked into the repo in that project.
And I remember this, so it'll be sample code to kickstart, but I can just as easily pull that down, replace it with my actual code that I want to go into production, check it back in, and it's set.
Yep, that's it.
Okay,
Right.
cool.
And it will give you a CI and CD pipeline that makes sense for the technologies picked. So in our case, we chose, what did we choose? We chose Node into a Kubernetes cluster, right?
Right.
So it's going to have a build that makes sense for Node. So I'm going to guess it's going to do some type of Helm type of build, and then it's going to use Helm to deploy into my Kubernetes cluster, right?
But it's also spinning up everything necessary to create that cluster.
Yes.
Okay.
So remember, I didn't start with the cluster. So it's creating the cluster from me from scratch as well. So when it's all done, you end up with a screen that looks like this, right? And this is kind of cool because it shows you everything that is created for you. On the left-hand side, you have your CI/CD pipeline. So from your code to your build to your release, to here's my repository with all of my code, to my Kubernetes cluster with my sample app that's already deployed. Right?
Nice.
So these are all deep links. So if you click on it, it will take you to the resource that it created for you up in Azure. So if I go ahead and click on the repo, you'll be able to see the actual repository with the sample code that it created for us. Right? So this is kind of neat. What I wanted to show you is we have our application, and we also have all of our Helm charts.
And for those not familiar with it, Helm is a way to simplify development with Kubernetes, correct?
Yeah.
It's a way of basically you have different pieces of your application, and Helm is sort of a prescription for how those pieces go into containers and deploy out to Kubernetes.
It describes your Kubernetes cluster and how you want to deploy your application and things like that.
Okay.
And the other interesting thing is it also has ARM templates.
Nice.
Right?
So those are Azure Resource Management templates.
Absolutely. Right. So what we're doing now is infrastructure as code. We have an ARM template that describes our Kubernetes cluster. We have Helm templates that describes our app that's going to be running in our Kubernetes cluster. We have our app itself in the application section. So here is the application itself. So we have all the parts for it, right? The infrastructure is described using ARM templates. The Kubernetes cluster is described, and also the source code is all there. Now, this is all just for the sample, right?
Okay.
We also have a build pipeline. So let's go ahead and look at our pipelines. It creates for us a build pipeline that makes sense for the technologies picked. So in this case, it's going to create a build pipeline for us that creates our Docker image and then creates our Helm package, right? And then stores the Helm package as a release artifact or a build artifact.
Okay.
So if this build is successful, it then sends it through a release pipeline. And the release pipeline is just one environment now, but it will go ahead and deploy into the Kubernetes cluster. And if you look at the very first task that it does, it's going to use that ARM template to first deploy the cluster and then deploy the application on top of that.
Wow. And it's a nice clean separation too. We've got all of our artifacts that come out of the application.
Yeah.
Here's our code, here's our template for how it's going to get deployed. Then on the release side, build the infrastructure, use those artifacts to deploy the project into it.
Yep, absolutely. Nice. And everything works, right? So here's the application, it's all deployed. And here's the sample app deployed in
Success.
my Kubernetes cluster.
Awesome.
So easy enough to swap out our application, right? Because that's what everyone asks, which is, okay, great, you have this pipeline, now I have my Kubernetes cluster, but how do I get my real application into this cluster now? Once again, this is nothing more than just this is just a Git repository, right? So if I go ahead and jump into my repo, a couple ways we can do this. We can clone this repo onto my hard drive.
Modify the code.
Modify the code, keep the ARM template, keep the Helm charts, and put my application code in there, check it in, and then it should flow through the pipeline.
Okay.
Right. Another way that I often show is in our release pipeline. One of the first things that it does is it goes ahead and, I'm sorry, I really should be at the build pipeline. One of the first thing in the build pipeline that it does is it gets the code from source control. Right. So here's my get source.
And then you have options to point it to another source repo.
Point it to your own repo.
Yep.
Right. So the demo that I always choose is, my code is up in GitHub. Let me go ahead and grab that. Let me go ahead and authorize this. And it's going to authorize using OAuth, or I think I've already authorized, which makes it easier. And then we'll go ahead and choose. Let's choose, what did I choose? This was a Node application, right?
It was.
So I better choose another Node application. Let me go ahead and do that. We'll save this, queue it up. So now it's going to go ahead, download the latest code, but instead of from Azure repos, it's going to grab my GitHub repo that I just selected, and it's going to go ahead and build it, turn it into a Docker image, and deploy it into my Kubernetes cluster.
So what you did, though, you didn't get rid of the Helm templates and the other things generated. You just changed where it's going to get the application source code. Okay.
Yep, that's it. That's it. And when it's all done, it should deploy everything out. Here's my lovely Node application, all deployed.
Nice. Right. Fast, unopinionated, and minimalist.
right. So that's the whole point, right? We want to speed up this whole process of creating that pipeline. Now, most of the time, it's not quite this smooth, right? I mean, this is a demo, so I've made sure everything was working. But most of the time, you would come in here, this template would fast track you. You have a build, you have a release, and then you might want to customize that.
So you start tweaking.
Yeah. So you'd come in here, you'd tweak it by adding or removing tasks, or maybe you want to change your cluster up a little bit or do whatever. But 90% of the work is already there and you're ready to go.
Nice.
Right. So this is one way of doing it, using the Azure DevOps project.
Cool. So there's another way, though, if I'm a command line person, you said.
I am kind of a command line junkie and open source junkie as well. So I like using a tool called GeoTeams. Right?
Okay.
It's actually created by Donovan Brown, but it's an open source project. This uses Yeoman, which is a scaffolding tool based off of Node, I think.
Okay.
And using Yeoman, you're able to scaffold out basically you can see the type of pipelines that you can create. You can create containers, you can do .NET, Java, Node, whatever, and you can choose whatever you want. So the way you get started using that, if you don't want to use the Azure DevOps projects, is what I usually end up doing is I Google YoTeam. And the first thing it gives you is there's a blog post that Donovan talks about everything about YoTeam, and also his GitHub repo. Right?
Okay.
I like his GitHub repo because in that repo, it tells you everything that you need to in the README file, including how do you install this and how do you use it.
Okay.
To install it, easy enough. Let's bring up a command line. You do need to have npm installed.
Okay.
So let's do an npm install, and it says go ahead and install Yo first. So this will install Yeoman. And after we install this, we'll install the team generator that he created.
Okay. So Yeoman itself is a project for scaffolding all types of things.
All kinds of things.
And it's completely extensible, so if I want to create my own type of scaffold or template, I can do that. And so what Donovan's done is taken advantage of that and built a set of scaffolding specifically for Azure DevOps.
Absolutely.
Got it.
For Azure DevOps and also Azure. All right, so we've just installed Yeoman. Let's go ahead and do an npm install. Is it generator-team? Yes, generator-team. So this installs the team generator for Yeoman that Donovan created. And once this is installed, we can go ahead and start using YoTeam to scaffold out our project. And I'll show you how to do that in a second.
Awesome. It's ready for you.
Awesome. All right. So what we're going to do is just type YoTeam. And it's going to ask us a couple different questions. And we just basically walk through this wizard-like interface through the command line. And the first thing it's going to ask us is, what instance of Azure DevOps do you want to create this pipeline for? So Azure DevOps Demo A, that's the one that I use, so I'm going to go ahead and select that. It does need a personal access token.
Okay.
Right. So to get your personal access token, easy enough. Let me go ahead and jump into an instance of Azure DevOps here. Here we go. If you click on your own little icon and go to security, from here, you should be able to create a brand new token. So let's create a new token. And the new token that I want to create, I do want to give it enough rights to do what we need it to do. And let me go ahead and refresh this because it looks like my browser is being a little weird.
Here you go.
And the name that I want to give it, let's call it on.net scaffold demo. And 30 days, that's fine. We'll give it full access. Let's go ahead and create. Now we have our token. Right?
Okay.
So I'll go ahead and copy that. I'll paste that in here.
And this is great because it doesn't require you to enter your password. You're
Yeah.
basically generating a token just for this process, so you don't have to share any credentials.
Yeah, don't have to give the username or password. I can track who's using this token, and if I need to, I can deactivate
You can
just this
revoke
token.
it. Yep, great.
All right, so it's connected now. My YoTeam instance is now connected with my Azure DevOps instance. So now it's going to ask me, what agent do you want to use?
Okay.
Right? Do you want to use a hosted agent, your own agent? Do you want to, or which agent? So I'm going to use well, for this one here, let's go ahead and use an Ubuntu agent.
Okay.
And now it's going to ask me, what language do you want to do? Do you want to do .NET Core, Node, Java, or PowerShell? For this demo, let's do .NET Core, since we're a .NET shop. And name of your application, we'll call this Test App 4.
Sounds good.
Hit Enter.
Very creative naming.
I know, I'm super creative that way. Now it's going to ask me, what infrastructure in Azure do you want to deploy this into? App service, container, ACI, Docker host, Kubernetes. Kubernetes takes a while, so I'm just going to go ahead and do app service because it's pretty fast. But let's do app service with deployment slots.
Okay.
Make it a little bit more complicated. Hit Enter. Now it's going to go ahead and access all of my Azure subscriptions because it needs to ask me which Azure subscription do you want to use to deploy everything out to.
Right.
So I'm going to go ahead and deploy to my Able subscription. And we'll go ahead and do an automatic service principal, install the dependencies, and yeah, that's all we need to do now.
And then it's off to the races.
It's off to the races. It's going to go ahead and create for me. Now, what is it going to create for me? Same thing as last time, right? Sample code in the language that you picked. So in this case, it's going to be .NET Core. It's going to include for me my ARM templates and everything else that I need. And then it will create for me also a team project in Azure DevOps. And then it will create for me a CI/CD pipeline that makes sense for the technologies picked. And then because we're deploying using an ARM template, when we deploy, it will deploy the infrastructure out into Azure as well.
Nice.
Yeah. So it's downloading the source code. Now everything is ready. And all we have to do is push, and we're pretty much done. So if we look in here, let's go ahead and CD into our test app 5. Do a git push. And that should push all this sample code into the repo, which should kick off the build and release. So if we jump into Azure DevOps, let's go ahead and close this. You'll be able to see that we've created a team project called Azure DevOps Test App number 5. And we'll go ahead and jump in here. And from here, you'll be able to see here's our repo with the code that we just pushed in, including all of our templates. We have our pipelines. Here's our build pipeline. And once again, it's going to create for us a build pipeline that makes sense for the technologies that we picked. So in this case, it's going to be a .NET Core application.
With testing.
With tests, with unit tests, including the ARM template. And then we'll go ahead and deploy this. And when we deploy this, this is actually kind of cool. Let's go ahead and edit this. And from here, we have a dev environment, a QA environment, and a prod environment.
Okay.
And we're deploying into app service, and we're using slots, deployment slots.
So it's going to swap those out, basically. Deploy to a, I don't know if you would call it a canary, like a test slot. Yeah. Everything's fine, swap them around, good to go.
Yep, yep, yep. So just like before, right, this really fast tracks your whole, oh, I've got to create the pipeline, I've got to create the infrastructure, how do I do that? Well, guess what? Just use YoTeam, answer a couple simple questions, and you're ready to go.
Awesome. Thank you so much for showing. We have 2 ways to build our pipelines.
Yep.
The portal, the command line, and pretty much it looks like almost an infinite combination of possibilities depending on what language I want to use, what framework, and even how I want to deploy the application.
Yeah.
Powerful.
Yeah. So the key things that I want developers to understand, especially our .NET developers, is that I don't want to hear the excuse of, oh, I don't want to create a CI/CD pipeline. It's such a pain.
Right.
Whether you're using Azure DevOps product or whether you're using Donovan's YoTeam, we can scaffold out your preliminary pipeline super, super easily. So from the very beginning, right? From the very beginning, you can start with a pipeline and be DevOps ready.
And you have your full CI/CD within literally minutes. We saw this live as you were building it.
Yep.
Awesome.
Hey everyone, Donovan Brown here. Welcome to the DevOps for ASP.NET Developer Series. Azure DevOps allows you to use as much or as little as you like. Thanks to the numerous integration options, you don't have to rip and replace what you have today to start using Azure DevOps. For example, if your code is already in GitHub, you can leave it there and start using just the features you need from Azure DevOps. Let's see how Abel and Jeremy integrate Azure DevOps and GitHub.
Abel, we've talked about a bunch of different ways that we can share or store source code with Azure DevOps.
Right.
And in Azure DevOps, we have options to do distributed and non-distributed source control.
Correct.
But I think what intrigues me the most is the ability to plug into other source control repositories like GitHub. Mm-hmm. And GitHub is so important because so many open source projects are on GitHub. And I understand there's direct integrations between GitHub and Azure DevOps.
Yeah, we really wanted to build a first-class experience between GitHub and Azure DevOps so that there really is no type of gap, right? If you're using GitHub, it should make perfect sense that you want to use Azure DevOps as your DevOps tooling.
Very cool.
Yeah, so like I said, first-class integration. And the way that we've done that is we've built integration between Azure boards, the way that we track our work with GitHub, and also we've integrated our pipelines, our build and release pipelines, with GitHub as well. So let's go ahead and check it out and see what I mean.
Awesome.
All right, so on my screen right now, what you see is a sample of an Azure board, right? We've talked about this as well. Inside of Azure board, you have the ability to track any unit of work in your software project. Now, in GitHub, there are issues, right, that you can track. But that's not very powerful, right? If you're just tracking issues, that makes sense. But if you want to track from sprint to sprint, it's really nice now to be able to use the power and flexibility of Azure boards linked to GitHub.
Right, so you basically can organize what does my work look like over an increment as opposed to I just have a huge list of things to do.
Right. So to actually link your Azure boards to your GitHub repo is pretty simple. So from your project, go to your project settings, and then
does this assume that I've created an Azure DevOps board first?
Yes.
Okay.
Yes. So you've already created your Azure DevOps project, you have your board, and from here you go into your project settings, and you'll go into, underneath boards, there's a GitHub connections. And from here, we'll go ahead and click on it. Let's connect to our GitHub account. Now I've already authenticated, otherwise you'd have to type in your username and password and two-factor authentication and all that stuff. And now it's going to want you to connect up to your GitHub repo. Right?
Okay.
So here's a list of all of my repos. We'll go ahead and just grab one of them, my Able Tailwind front end. That's good enough. We'll click on Save. And literally, that's all you need to do now. Now, my Azure board is connected with that specific GitHub repo.
Okay.
So let me show you what I mean. Let's jump back to our boards. And let's go into our Kanban board. And for this demo, let me go ahead and move this over to the side. Let me go ahead and pull down my source code. So this is my Tailwind front end. If we go ahead and make some changes, let's add some changes, make some changes. We can do a git status. Let's go ahead and add our changes. And let's do a commit. Commit -m, made change for demo, fixes AB £65. Now you might say, why did I just say fixes AB £65?
I might say that. Why did you use fixes AB £65?
Because for this demo, I'm saying that this particular check-in is going to go ahead and fix from Azure board work item number 65.
Okay, so you're referencing from that commit the board item.
Yep.
Got it.
So let's go ahead and hit enter. And then we'll go ahead and push this back up to GitHub. Now, the magic is where I say fixes AB pound, right? Because by doing that,
I just saw it move.
yes, you did. By doing that, it linked that check-in to this particular work item. So now any work that you do in GitHub, as long as you flag it with AB pound, whatever the number is, it's going to automatically link it to that particular work item, including using verbs like fixes, which takes it from an active to a resolved state. Now, if we jump into the work item itself, you'll be able to see the work that we did is now tracked underneath development. And this, of course, is a deep link back into GitHub. So if I jump in here, click on it, it takes me into GitHub, into the change set, and you can see exactly what changes were made.
Nice.
Right. So the integration goes both ways as well. So if you're in GitHub and you want to make a check-in, so let me go ahead and jump into GitHub. Let's say we update my README file for some reason. Let's go ahead and update this really quickly. We'll make a change. And from here, we have to wait for my screen to refresh. And we'll add something. Now, if we come in here, check this out. If I say fix for demo, AB pound, or let's do a pound, just like that. All of a sudden, it's going to start showing us all of the work items that's already linked to our Azure boards.
Okay.
Right? So now I can link my work items like this as well. How cool is that? So
Nice.
It goes both ways. It's not just from Azure DevOps. It's from Azure DevOps and also from GitHub as well. So it's true two-way integration for Azure boards for GitHub.
Got it.
So that's the integration between Azure boards and GitHub, using the power and flexibility of Azure boards to track your works for your open source projects as well.
Now, if I create a issue on the GitHub side, will that reflect on the Azure board as well?
At this moment, it doesn't. It doesn't go that direction, but I think that's in the plans.
Okay, very cool.
Yep. The other thing that I wanted to show you as well is this is great for tracking our work, right? But what about build and release pipelines? From GitHub, how easy is it for me to create a build and release pipeline? And the answer is it's actually super easy. Let me jump back to my repo again. And from my repo, what you need to do to create your CI/CD pipelines and Azure pipelines is you have to install the GitHub Marketplace extension for Azure pipelines.
And that's something you install at GitHub?
At GitHub. So from GitHub, right, let's go to the Marketplace. And from GitHub's Marketplace, we'll go ahead and search for Azure Pipelines. And here, we'll be able to see the extension that we need to install. Now, I've already installed this, so we'll just go ahead and jump in and configure it. But when you configure it, it's pretty simple. First, it's going to ask you for your password. Then it's going to ask you which repo do you want to create your pipelines for. So if we go ahead and scroll down, we can say every single repo in my GitHub account, which is insane. I don't quite want to do that.
Right, I wouldn't want to do that with mine either.
So we'll just go ahead and you can select which repository you want, click on Save, and then it's going to now redirect you and take you back into Azure Pipelines where you have to log in. And after you log in, it's going to ask you which subscription do you want to use, which project do you want to use. So we'll go ahead and do that.
So while you're doing that, what's key for people who are running open source projects is we provide the pipeline service free. So if I have an open source .NET project on GitHub and I want to automate my build process, I can go in, take these steps, and at no extra cost to me, I've got automated builds.
Yes, absolutely. Right.
Nice.
So even for your open source projects, you can have really complex, powerful CI/CD pipelines as well. Right. So you select your subscription, you go ahead and select your project. We'll go ahead and click on Continue. And now it takes me into my Azure DevOps subscription, and we'll be able to see all the repositories. And from here, we can go ahead and say, you know what, for this, let's go ahead and create my build pipeline for me. So the first thing that it does is it goes and actually examines that repo, figures out what's in the repo based on the technologies, and suggests some type of install, or some type of build, right, using a YAML build. So then we can go ahead and save this, and hooray for that, we're ready to go. Now you have your build and release pipeline all set.
And it gives me the right template to kickstart based on the type of code. So if it's .NET Core, it's going to do .NET Core steps. If it's Node, it'll do Node steps.
And just like before, right, most likely, you're going to have to go in, you're going to have to tweak the build, tweak the release a little bit to make it do exactly what you want it to do. But it's going to take you 90% of the way there.
Nice. And I noticed this is stored in a YAML file.
Yes.
So I'm assuming that means if I have a custom build process that I do for most of my projects, I would be able to easily take this and paste it into a new project to reuse it.
Yeah, I really love YAML builds precisely for that reason, right? So a YAML build is you have your build definition, but you describe your build definition using a YAML file. And that same YAML file is checked into your source code repo right alongside your code. So now your build definition is versioned right alongside your code, which makes it super powerful because if somebody forks your repo, like you were saying, or maybe clones your repo, not only do they get your source code, they're going to get your
They inherit
build.
your build,
yes,
which is nice.
Which is really, really nice. And not only do they inherit your build at that moment, it's the build for that version, right? So even if your build definition changes as time goes on, it's versioned right alongside your code. So as long as you do a get from your repo, your build definition and your source code, that's always going to be in sync.
That's great. So whether I'm an enterprise that's using GitHub to store my source code or I'm an open source project maintainer, either way, this is an easy way to track both issues, source control, and automate my builds.
All right, so there you go, right? Super powerful integration between GitHub and Azure DevOps. So like I said before, what we wanted to make sure is even if you're using GitHub for your open source projects or your social projects, we want to give you first-class DevOps tools by using Azure DevOps.
That's awesome. And speaking of Azure DevOps, this has been a multi-part series. We've sat here and gone through all phases of Azure DevOps. I just want to say for .NET developers, Abel said it before, there's no excuse not to have continuous integration, continuous deployment. All of the tools are available, straightforward and easy, and we hope that this series has not only introduced you to what's available and what you're capable of doing, but also has made it easy to, regardless of whether you're looking at source control, automated builds, testing, unit testing, we had release pipelines, all of that's there. Feel free to dig deep and explore, and just happy to have shared this tool set with you.